Today's May 30th, 2019. I'm BrentNally, and I'm here with Dr. Bill Andrews. We are at his headquarters of Sierra Sciences in Reno, Nevada. And if you haven't yet, I have in the description below a link to the book review that I've done on Bill Andrews' most recent book. He'll have another book coming out soon. So hopefully you can check out that book review and you can learn a little bit more about his credentials in that video as well. Bill, thanks so much for sitting down with me.
Thank you.
And my wife is here behind the camera, Lauren Nally. We made the drive up today. And just wanted to start off by, first of all, learning a little bit about you and your background and how you thought about, how we're going to cure aging from a young age or was a little bit older. If you could talk a little bit about that, that'd be awesome.
Well, I didn't figure out how to do it at a young age. I just decided at a young age that this is something that sounded like a good use of my life, was to figure this out. But it all started when I was 10 years old, approximately. My teachers in school were always telling my parents that I was super interested in science and medicine, and that something that they should promote with me. And I was, outside in the front lawn one day when I was 10 years old, looking into a telescope at the stars and stuff. And my father came out and side and said to me, Bill, since you're so interested in science and medicine, when you grow up, you should become a doctor and find the cure for aging. And he also said, which surprised me today, he says, I don't know why nobody's done that yet. Because apparently he thought this curing aging would be something simple to do. Well, I thought it was simple. I thought it'd be simple too. I just got really locked into that. And I all through high school and college, everybody knew me as somebody that was determined to go and find a cure for aging. The problem is that nothing made sense. I mean, the whole field of anti-aging has got more quacks and charlatans than anything other field on the planet.
Yep.
So there's all these kind of stories out there. Everybody's trying to make a buck, trying to convince somebody that their aging's going to be cured if they do this or that. And none of it's true. But it led to a lot of theories that just never made sense. I could spend a lot of times, most of the theories revolve around we age because of the environment. But if that was true, if that was the cause of aging, why is it the people who live on the North and South Poles age at the same rate of people who live on the equators? The environments are different. And why do dogs and cats age at different rates than humans when they're in the same environment? There had to be something else. Even in high school, and mostly in college, when I was doing research on fruit flies and studying the aging process in fruit flies, I was saying there has to be some kind of clock that's ticking inside of our bodies. And that clock is just set differently in cats and dogs. And it's got to be a real simple clock. It can't be super complex, because the fact that dogs and cats are pretty consistent, and then different breeds are very different from each other, even in the dogs. So there had to be some switch, something that you could manipulate to change that, because it was being manipulated by accident already. So I just kept on searching. I kept saying all the twos and twos have to add up, and they just didn't. People like to think we're no different than trucks sitting out in a field, exposure to the weather, the rain, stuff like that. And but we aren't like that, because the thing that we have, humans have, and other animals have that trucks don't have, is when we get a sunburn and kill cells, humans have other cells that can divide to replace those dead cells, whereas an old truck sitting in a field cannot. So that's the really big difference. So that's why trying to compare us to an old truck sitting in a field just doesn't make sense. But that just said, we have cells that divide that can replace those dead cells. Why does that fail? Why does that quit working? Why do we get older anyway? That was the big question. So that was where I kept thinking, there's got to be something going on. And then one day, this is when I was in either college or early graduate school, somebody told me about something called the Hayflcik limit. A guy named Leonard Hayflcik in 1961 had shown that you could take human cells, grow them in a petri dish, and they would only divide a certain number of times before they would stop dividing. Well, people would argue, oh, that's just stuff in the growth media. They're running out of certain nutrients or something like that, and they can't divide anymore. But what he showed was that when he took cells from a newborn baby and grew them in a petri dish, they would grow like 60, 70 times, divide 60, 70 times before stopping. When he took cells from like a 40-year-old, they'd only divide 30 times before stopping.
Yeah.
And when he took cells from a 90-year-old, they'd only divide 10 times before stopping. Well, the growth media was all the same. There was something about these cells that was telling them how old they were.
And were these, real quick, were these stem cells or differentiated cells or all sorts?
These were skin cells. These are just regular skin cells. And it wouldn't have made any difference. There's theories going around that stem cells don't have this phenomena, but they do. It's like if you actually go to the scientific peer-reviewed journal studies, you'll never find any study that says that stem cells don't have a Hayflcik limit.
Right.
They have the Hayflcik limit just like every other cell. The only exception is human embryonic stem cells and induced pluripotent stem cells. Those cells have overcome the aging process and the Hayflcik limit. And that's important because we couldn't exist as a species if our children were born with older cells than we have.
That would be bad.
Yeah, and but that's not true for most stem cells. Most stem cells still have the Hayflcik limit. They still have what are called telomere shortening. But I kept thinking there's got to be some kind of clock. The Leonard Hayflcik's study was I think a very important clue. After when I was close to getting my PhD, I applied to practically every lab in the world that was working on anti-aging, and I got accepted to every one of them to be a postdoc in their lab. When I went and met with them, I said, let's look at this Hayflcik limit. Let's figure out what's going on there. And every one of them said, no, our focus is on something else. Couldn't find anybody that wanted to really start figuring out what's causing the Hayflcik limit. And so I said, okay, the world's not ready for this. It's people these charlatans just want to find a way to make money and stuff. I just thought everybody was either a quack or something like that. So I decided to forego temporarily my research to cure aging and went into biotech instead as a senior scientist.
You had to make some money and have a career, right? Is that
at the same time,
main reason?
Keep an eye on the field,
right?
Okay, to find out something came on, and I made it really clear when I went to these biotech companies that my major interest was aging. So every time there was some kind of project that we could do, like to look at osteoporosis or anything that would affect aging, I'd be the project leader and focus on trying to study what's going on there. But still, nobody was coming up with any explanations as to what that clock might be. Then in 1992, I attended a conference in Lake Tahoe at the Grand Labakan in Tahoe City. And surprisingly, I actually met with some scientists and talked them all into organizing a biotech company to do research. My father was the one who put this seed in my head to begin with. He actually was very interested in aging. He actually went to the conference with me. He was a television producer at the time. He wanted to make a documentary on scientists interested in trying to find a cure for aging. So we're having meetings and things like that. But I talked to a few of them into starting a biotech company. And so we started a company, stayed up all night talking about I was going to be the president of the company. It was going to be called MRX for Methuselah Research. Next day, I attend the lectures, and this guy named Calvin Harley, Dr. Calvin Harley, talks about telomeres. And he mentions that telomeres at the tips of our chromosomes, they shorten. And he said that I can take cells from any of you, I can measure the length of your telomeres, and I can tell you how old you are. And more importantly, I can tell you how long it'll be before you die of old age. Now, he couldn't say at the time, was telomere shortening a cause of aging or a result of aging? But he did mention that this telomere shortening does not occur in our reproductive cells, so the essentially human embryonic stem cells.
They don't get past the germ line.
The germ, what do you mean? I said I don't know what that means.
The germ line is what protects us from our human reproductive cells. It's called, if you just Google the germ line.
I know exactly what a germ line is, but I think you might be.
Am I confusing something?
Yeah.
No, you can include it. You can call me out. We're all good.
The germ line is the entire cells, that go through multiple different stages in producing the sperm and the eggs. But the primordial germ cells are the ones that we have to be talking about. Those are the ones that are immortal. They're what the human embryonic stem cells derive from.
Gotcha.
They're cells that grow inside
That's
our
what
body.
I was referring to. I just didn't know the exact,
Because the germ cells is a whole long process that has all different kinds of stages. But he had mentioned that the reproductive cells or the primordial germ cells don't have it. And it's important that they don't, because if they did, if we had telomere shortening occurring while we were producing our egg and our sperms,
those babies would come out old.
Our children are born as old as we are. Yeah, and we'd be extinct as a species after a few generations.
My wife's pregnant right now. We don't want to have a 34-year-old baby, right? That'd be bad. She agrees.
So the guy said there had to be some kind of something going on in the reproductive cells, and maybe there was an enzyme called telomerase that existed in our reproductive cells that was explaining why.
He said maybe because the tetrahydrogen that was discovered in '84 has a telomerase enzyme, and he was already thinking there's got to be one in humans.
Close, but I'm going to come to that. So, because
sorry to jump the gun.
The problem is that the people had discovered an activity that lengthened telomeres in this pond scum organism called tetrahymena, like 10 years before. Okay, this is Elizabeth Blackburn and Carol Greider. They had discovered this, they published it, and then never connected the dots to anything. It was just an interesting activity. They saw, something's making telomeres get longer in this organism. They ended up discovering a piece of the activity, what's called the RNA component, and they didn't call the enzyme telomerase. They called it terminal. Now I'm going blank away. I think it was terminal telomere transferase.
Okay. Are you saying in this little pond scum? Okay.
Yeah, they found it, but they published it, I think, in 1984, and then moved on. I didn't do anything about it.
Right. On to the next discovery.
In the 1990s, Calvin Harley published a paper called "The Telomere Hypothesis of Cellular Aging," I think is the title of the paper. And that he proposed that maybe there's a similar enzyme in human cells that was keeping the reproductive cells from getting shorter, and that maybe we could find that enzyme, and if we found it, we could address the question: is telomere shortening the cause or result of aging? Things like that. So he's describing all this. I'm sitting there thinking, okay, people in the North Pole, people on the equator, South Pole, dogs, cats, this explains it all. I said, this is all the twos and twos add up for the first time ever. And so I before he even got off the stage, I was at the bottom of the stairs as he's coming off the podium, and I said, has anybody discovered this enzyme yet, telomerase? He says, no, we've been working on it for years, working with these women, Carol Greider and Elizabeth Blackburn, who had discovered this activity in this tetrahymena, but they only discovered a piece of it, and they never discovered the rest of it. But I already had a very successful background in biotech. I'd been involved in a lot of the big biotech blockbusters, and Cal Harley knew this, and I just said, well, if you guys haven't figured it out, let me come and work with you, and I'll have it discovered in 3 months.
So you were working at a company at this time, and it had that much of an impact on you that you were basically like, I'll quit my job and I'll come work for you to do this.
Well, even I was at my other company, which is I first was at Armos Corporation. That failed. I was recruited to Codon Corporation. They became Burlex Biosciences. That was the greatest company on the planet. I used to say I was a lifer. I'm never leaving that company. I was the director of molecular biology. But they all knew I was interested in aging. And this came along. I was sure they would completely understand, and they did, why I was jumping ship and going to work at Geron. But Cal Harley offered me the job, probably shortest job interview ever, but because he knew of my background. And so I guess it was 1993, December of 1993, I started saying that I was going to have it discovered, have this enzyme telomerase discovered in 3 months. Him and his other people who were like the president of the company, they put 3/4 of the company reporting to me. That was something like about 30 people. And so the big mission was I was directing this effort to discover, excuse me, discover telomerase. Well, there was a few little obstacles that got in the way, and most of it were, let's say, people trying to control science, sending us off into different directions. So I didn't get it done in 3 months. It took me 3 months and 17 days. But and I don't want to say me, it was my team.
You studied that, yeah.
Yeah, and so it was like, so I always say I led the team that discovered telomerase.
That's what I've heard you say in other interviews and things, so yeah.
And what I can say is that because of computer software that I had written over the years and stuff like that for analyzing RNA structures and DNA structures and things like that, I had built some kind of computer models to say what would, to take a good guess as to what telomerase would look like. And so we started getting these candidates from our research at Geron Corporation, and I was analyzing each candidate just based on sequence, DNA, RNA sequence alone, folding them up, looking at structures and stuff like that. And one day I come walking out of my office and I say, we found it. You know, this one molecule, I showed structures of it, I showed everybody this is it. Everybody said, wow, the probability of a RNA having that kind of structure by chance was so small that this had to be it. But so that was the 3 months and 17 days.
Wow.
Okay, so unfortunately, you can't just say that and everybody else is going to believe you. So we had to do some research. What we did is we in the structure, because the only thing we knew about human telomerase is it somehow produced the 6 bases called TTAGGG that's repeated over and over again in telomeres. We didn't know anything else about it at all. We did question whether it might be similar to the RNA component that they discovered in tetrahymena. But so I did have some scientists working on that possibility, but it was clear right on the get-go that there was probably no similarity between them. So we were working from scratch, and the reason why everybody else couldn't discover it is because everybody was assuming it had to be similar to the one in tetrahymena. So my focus was on forgetting that there might be any similarity and focus on just finding it from scratch. And we only knew 6 bases, which is like phenomenally little information. But combining with a lot of best guesses and stuff like that, we came up with something. People like Bryant Villaponteau and Junlin Fong and Walter Funk and things like that, people that were working with me, were brilliant in designing different schemes to come up with these candidates. I was analyzing the candidates, and I was finally said, this one's it. So to prove that it was it, what we did is we mutated it. We figured out the best guesses as to how it worked, how it did its job, and we mutated it. So instead of producing TTAGGG, it would now produce TTGGGG.
How did you do that?
Well, we just made a mutation. We figured out how does this molecule tell the cell to make a TTAGGG repeat.
Okay.
And we changed it, which is like a computer program. We changed the computer program so that now this molecule is going to tell the telomere to become TTGGGG. We also did TTTGGG.
Okay.
Okay, so we came up with 2 different ones. And we then took these mutated molecules, put them back into cells.
Into human cells,
into
right?
Human cells, grown in
skin cells, or?
Skin cells, yeah.
Okay.
The most common human cell to work with is called a fibroblast cell.
Okay,
yep. That's because it grows fast, and even if it gets contaminated, it can outgrow the contaminants. But we then introduced this telomerase molecule into the cells.
Mutated telomerase molecule.
Mutated one.
Right.
Let the cells grow a while, then harvested the cells and sequenced the telomeres. And lo and behold, we were right. They were TTGGGG or TTTGGG. That proved that we had discovered it. And the letter I showed you, you filmed before, out there in our hallway,
yep.
describing that experiment, showing how we changed this length of the telomere by mutating this molecule, which proved that this molecule was telomerase.
So what Dr. Andrews is referring to is we did a tour of the office here that we'll show probably after this video, I imagine. Hopefully the audio is good in there. We didn't have these microphones hooked up, but he showed us tons of great pictures, the lab, robotics, and he showed those pictures in there. Yeah.
So
I've never heard you tell this story, and I wasn't expecting it. So this is a super surprise.
I don't
for me.
have a. Every time I talk, it's different. I don't ever remember saying everything I just said now, but so this is the first there. But one of the big things was we knew we'd only isolated one component of telomerase. There had to be another component. There had to be a protein component, and we knew this partially by the fact that if you were to take an enzyme that degrades RNAs, that would destroy telomerase. But if you also took an enzyme that destroyed proteins, that would also destroy telomerase activity. So that there had to be an RNA component and a protein component at least to actually have this activity. Now, Carol Greider and Elizabeth Blackburn, they had started research. Now, okay, so after Calvin Harley published the paper, The Telomere Hypothesis of Cellular Aging, they then got on the bandwagon. I don't know. Maybe they realized that, oh shoot, this is actually
making sense.
Opportunity, and we never even thought about this. And there's documentaries. There's a documentary called Decoding Immortality. It actually used to be called Immortal, and then they did some editing and it came up with a newer version called Decoding Immortality. And in there, you'll actually hear them both talking about, we had no idea. We discovered it was an interesting piece of science, but we had no idea that this had anything to do with aging and cancer and stuff.
Before I forget, I want to give a quick plug for you while you're talking about documentaries. The Immortalist is a fantastic documentary from 3 or 4 years ago or so that basically follows you and Aubrey de Grey.
Dr. Aubrey de Grey.
Dr. Aubrey de Grey. And that is a fantastic documentary, which I bought on YouTube and has probably watched like 6 times. I'll probably watch it again. I haven't watched it this year.
Well, it's really exciting because it almost won an Oscar.
It should have.
for best documentary. I mean, the producers and directors were the best. I didn't understand what they were doing, but when they actually put it all together, I was blown away with how good. Normally I don't watch stuff about myself, but I watched that at least 20 times. I was like so impressed.
It's a very good.
The music, the way they organized, the entertainment, it was really good.
The production quality of this is not going to be as good. It's just my wife and I with the Osmo, and we're just trying to share this information. But I'll have a link in below to the Immortalist. I know you can watch it on YouTube. It probably can also get it on iTunes and Amazon and whatever.
But one day, all of a sudden, they learned that it had made it to the top 10. You know, how many new documentaries are out every year? Probably
especially
100,000.
about aging. I mean, most people are turned off about this stuff because of all the charlatans you mentioned. It's
but they weren't in competition just with the ones about aging.
Right.
They were in competition with every new documentary.
Right.
And they suddenly got noticed that they made the top 10. That's about maybe 100,000 new documentaries every year. Mm-hmm. They made the top 10, but only the top 5 get nominated at the Oscars. They didn't make the top 5, but the top 10 was like, we were all super excited. And I was a little disappointed, but it still was, top 10 was great.
It's very good. Check it out, guys. I'll have it in the link in the description below.
And Aubrey de Grey is a great guy. I mean, he's one of the most passionate people about curing aging I know, and I support him every bit of the way, and that's why I was glad that the directors and producers made the documentary about him and me.
I would personally put him and you like on the same level. There's other people who are very passionate, like Ray Kurzweil. I think I'm really passionate, but you guys are actually doing stuff like scientific research that's actually making it
I'm going to
reality.
say Aubrey probably knows a lot of stuff I don't, because he covers almost every aspect of it. I know a little bit about a lot, but not as much as he knows about a lot of other things. But he is the best at promoting the whole field. I mean, we're all following in his footsteps, trying to get funding and stuff like that. And he's the.
So I have a list of questions. One of the questions that I have is, I don't know if you know this about me. I'm into cryptocurrency. That's one of the reasons why my wife and I are fortunate enough to not have to be, working 9 to 5 jobs right now. and I think it's transformative. One of the things that Aubrey has said last year, he broke down crying because Vitalik Buterin, the founder of Ethereum, the cryptocurrency, donated $2.5 million to his SINS Research Foundation last year. And one of the greatest motivation why I'm sitting right here, I mean, I wanted to meet you in person. I've known you for a number of years. We've talked on the phone and message and stuff, but I want Sierra Sciences to get more funding. That's my greatest motivation for being here. And so we talked about this a little bit in the other lab, but you know, and you talked about your plan right now, which is basically other companies that aren't affiliated with Sierra Sciences selling products, and you are getting royalties, essentially. That's how you're generating funding, because the 2008 boom, investors were crushed, right, for Sierra Sciences, and it's been tough to recover from that. But you know, I've done a crypto vlog on my YouTube channel, and I'm hoping if there's any crypto people who happen to be watching this, that you would consider, if you have some money to, and you're a whale, I'm not a whale, to donate, because he's doing fantastic work here, which hopefully you'll see in this interview and in the tour that we'll give. So anything?
Well, I don't want to be a balloon buster.
Right.
And I'm very excited the fact that Aubrey has gotten that $2.5 million.
Right.
And he's been actually promised even bigger sums of money from other places that actually didn't come through. But $2.5 million isn't very much.
And I know.
Okay.
I know.
It's actually, because as I said, we were spending $1 million a month. I mean, $2.5 million would probably get us just a little over 2 months worth of work done. We need a lot more than that, and so does Aubrey. And so we got to still continue finding the bigger bucks, and that's what I'm doing. We are doing cryptocurrency. I don't know if you know about the Telomere coin.
No, please tell me. I'm not aware of that.
Right.
And
okay, so there's actually, let me bring it up right here.
Please do. Yeah. And that was just the one donation, just to be clear for the audience, from Vitalik Buterin. I believe he donated 2.5 million of Ether. There were other wealthy cryptocurrency donations that went to SENS. Basically, it's nowhere near where we need it, but it was a huge upshot because of the 2017 crypto boom, and because cryptocurrency people tend to also be in the anti-aging field, and they tend to kind of go, from my experience, hand in hand.
I can tell you for a fact that if we start getting large amounts of funding, I will be donating a lot more than $2.5 million to Aubrey's SENS Foundation. I just think it's too important. But this is the telomere coin.
Okay.
So when I say we are doing this, not Sierra Sciences, Defy Time has launched this coin on the BTCC Korea exchange.
Okay.
And they're going to do other exchanges too. It is actually
So that's on the exchange. Do you know, is it its own token with its own blockchain, or is it like an ERC20 token?
Terminology, I don't know.
Let me make it real simple.
Yeah.
ERC20 is a token that's on the Ethereum blockchain. Okay. And so it could have its own blockchain that stands alone, or it could be basically issued on an. If you don't know, that's totally fine. I'll figure it out.
You're talking to a guy that can tell you, I can read a DNA sequence and it can tell you what it does. I know the inside of a cells and stuff like that, but I don't know what the word blockchain means.
You focus on curing aging. I'll look into this, and I'll focus on making money in crypto, so we can hopefully get you guys a donation.
I want to bring up a page right now that shows the sales of it here.
Okay. And it looks like it's launching.
It's already launched.
It's already launched.
Yeah,
okay.
It's been out for a while.
Okay.
How to get to a page where we can actually see it?
It shows how fast things change. I never even heard of this.
Okay, here. So this is the exchange. Have you heard of the BTCC Korea exchange?
There's so many exchanges. So no, I have not heard of this one.
Defy Time is headquartered in Korea and Tokyo, so that's where they have it.
The Koreans love their cryptocurrency. I do know that.
TXY, the volume. It's actually, when you're looking on this list, it's actually one of the higher volumes.
18,615 volume.
There's two higher I can see.
Yep.
Out of like about 30 different cryptocurrencies. So
I'm definitely going to look into it, and
actually it's I don't know why it says
that's just the last 24 hours probably. So it's just down 10% in the last 24 hours,
but it's just a lot higher than it was yesterday when I checked.
So basically in the crypto market, things change fast. Things have been booming the last month, but they pulled back in the last 24 hours. So I checked this stuff on my phone. And
I don't know. I just know that Defy Time is one of those companies that has licensed things from us and is trying to get us funding for our research. And I'm hoping that before long we will be getting $2.5 million a month or more. But it depends on a lot of things. But one thing that people have to be aware of is that it does take a lot of money to do this research. So there's...
You've talked about this so many times, but just walking through your lab and seeing all the equipment and imagining first how much it costs to buy it, the insurance you must have on this stuff, the people you have to pay to run this stuff. I mean, it is... You guys will see the tour. It's not cheap.
Each of those robots were $1 million each.
Right.
Yeah. So it's that we have like 10,000 square feet right now of science. If you walk around, you might find 2 small offices where we call the business part of the company. The rest of it's just all science.
Yeah, this is a research science facility. So while you mentioned Defy Time, it was actually another one of my questions. So I still personally have not taken TAM818. Shame on me. But it's a product. It's a newer product that Defy Times creates, and you get a royalty for that, right? As we talked about before, you don't sell any products. Sierra Sciences.
In fact, I absolutely refuse. I don't want anything to do with marketing.
Correct.
I'll license it to them. They can market it.
You want to stay the science guy and the research, correct? So, but one of my questions was, I believe it was in January. Ben Greenfield interviewed you. And you were talking about certain things that you still do, and you said you still take TA65. So can you explain to the audience, TA65 is a product I've been taking for years on and off, and my wife. It's a telomerase activator molecule. Yeah. Why do you still take that if TAM818 is a stronger telomerase inducer? Or am I wrong on that? Can you just kind of explain that? Explain that?
There's several things out now that are true telomerase inducers. Okay, that actually work. For everyone that works, there's 20 out there that doesn't work.
Right.
so just don't be fooled by a lot of the charlatans out there. But we have given the Sierra Sciences seal of approval to about 3 different telomerase inducers that really work. One is TA65.
Okay.
One is isogenesis.
Yep.
And the other is TAM818 that's sold by Defy Time.
So to your knowledge, those are the only 3 products that actually induce telomerase that you know of. Is that accurate?
Actually, I'm going to say not to my knowledge.
Okay.
It's a fact.
Okay. Because if there was something else, you would know it. Right. You are the person who would know that.
Yeah. There's so many things out there where people are promoting it, but when you actually go look at the scientific peer-reviewed data, it's crap.
Right.
And we have tried to test them. We can't get it to work. We've called the scientists. We've talked to them. They're trying to tell us how to get it to work. They won't talk to us. There's the field of anti-aging is just filled with charlatans. That's the problem. And
I want to make super clear real quick to the audience. In this office that we're in that's massive, and you'll see the tour, this is what Dr. Bill Andrews and his team at Sierra Sciences does. So if there was another molecule that induces telomerase on the planet, then somebody would be keeping it secret, and it's that's very, very unlikely. Yeah. So
the reason why I take all 3 every day without fail, besides the fact that I'm just obsessed with anything I can do to slow down the aging process, I want to live forever, stay healthy forever. The reason I take all 3 is because so far we don't know the mechanism of action of any of them.
You just don't know how they're activating telomerase.
We just know that when we put them add them to cells in a petri dish, those cells start producing telomerase. We don't know how. Okay. We want to find how, but I'll tell you, want to find out how, but that's so much. That's very expensive too. It's going to be more than $1 million a month.
So then you're just wasting time and money on that. Like, it works. Let's just move on to the next thing.
We don't know the mechanism of action. We don't know how they're working. It's possible they're working by different mechanisms of action.
Okay.
And maybe they're synergistic.
Okay.
Okay. So maybe taking all 3 is better than additive of
maybe you could be making a new product then, all 3 of them together.
Well, it's like I don't make products, remember? I just do the research.
I know.
But I don't know why somebody else hasn't taken this ball and run with it. Why somebody mix all 3 of them together and sell them?
Well, because what you were telling me earlier, we don't know exactly what's in TA65. We just know that it works.
Well, they could go to TA Sciences and say, why don't we mix things with, be your product? They could do. I'm not a business person.
Right.
Maybe TA Sciences thinks that's a lousy idea or something like that. But I personally would, if somebody did that, I'd be taking it every day. Okay.
What about TAM818? Do you know what's in there, right?
Yeah, I do. I do know what's in there, and in fact, I know pretty much what everything is, except that I'll be the first one, even though the world thinks they know what TA65 is.
The cycloestrogenol.
I don't think it is cycloestragonol. Because our studies here we can get TA65 to work, but cycloestragonol doesn't work. I think it's possible even TA Sciences is letting everybody think it's cycloestragonol, so nobody figures out what it really is. So I have no idea.
I pretty much
out of the business.
I pretty much knew that, but you've answered so many of my questions. So I just want to be clear with these three products: the Isogenics, the TAM818, and the TA65. You're very confident you know what's in TAM818 and Isogenics, but you just are very skeptical that what is in TA65 is the cycloestragonol.
Yeah, and very skeptical would be the wrong word. I'm just going to say, I don't know. I don't want to guess.
But you do know what's in the other two, correct?
I do know that, like, isogenesis is a mixture of plant extracts.
Right.
I don't know what the active chemical is inside of those extracts that's using it.
And they're keeping that secret for their own privacy, or you just don't know?
The funding to actually identify those things hasn't come through yet.
Gotcha.
Plus, that would increase the price of the product a lot if there had to be a purification step.
As you mentioned earlier, but you've tested those in your lab, and you know that they work to induce telomerase. Gotcha.
We provide the Sierra Sciences seal of approval that they actually work. TAM818, we know the exact chemical structure. We actually designed it. We improved it. Our medicinal chemists made it better and better, also making it safer and safer. And we have more we want to do with it, but at least it's I think it's the most potent. It is the most potent telomerase inducer. Side by side, it produces a lot more telomerase than
a lot more. You mentioned in your book, how much more is it? Do you remember? I think
I'm not allowed. Because of confidentiality agreements I have with different kinds, I'm not really allowed to compare the three.
Okay.
But I can say that TAM818 is the most potent. And I think on Defy Time's website,
it says it on Defy Time's website.
They have data where they've compared.
This won't come out of your mouth, but I believe on the Defy Time's website it says 455 times more potent, I believe. So check that on Defy Time's website, everybody. Yeah. Fact check me there.
Now, given that, it's still not potent enough to actually win what I call the tug of war, telomere shortening and lengthening. It slows it down, but I think we only have to improve it 6-fold higher.
Because it's 13% potent right now?
16%.
16% now.
It produces 16% as much of about the amount of telomerase as is needed to stop telomere shortening.
Okay. And so when we were talking about earlier about not the germ line, but the reproductive cells.
Yeah, the primordial germ cells, yeah.
Do we have a percentage that you could state that you believe that telomerase is active? Is that 100%?
That's the 100%.
That's 100%. Yeah. And that's why our reproductive cells don't age and babies come out young.
Yes.
And so if we could theoretically find a molecule or just recreate somehow whatever's the telomerase activation in those reproducctive cells and the rest of our stem cells.
We're close.
Right.
Somebody's just got to give us some way of getting $1 million+ a month to continue that research.
So this is the main reason my wife drove up here. Why I've been doing all this work, for years. Talking with Bill and doing research online, and obviously he's done way more work for way many years. Getting people to understand that we're close. You're sitting here listening. He just needs a little bit more money.
And people got to quit believing all these charlatans that are just destroying the whole field by saying whatever they can to just sell a product, make a buck. That's it. I think we could be doing some pretty exciting stuff.
So, Dr. Andrews, I just thought of, if people are watching this video who maybe just don't know much about telomeres or telomerase, we just talked about, hey, we're close. Yeah. But can you talk about for a couple minutes what this actually means, telomerase, how it extends telomeres and why that's important? Obviously, it's all in your book. Watch my book review of his book, read his book, obviously, but a quick pitch for people who don't know this.
Well, okay, so telomeres are found at the tips of our chromosomes. And it was discovered in the 1970s that they shorten with age.
Right.
Of course, as I said already, people didn't know if this was a result of aging or a cause of aging.
The Hayflcik limit.
The
right?
Hayflcik limit. With just focusing on telomeres, though, because it took a long time before people connected telomeres to the Hayflcik limit.
Okay.
But I think that was probably Cal Harley that did that. But the telomeres were thought to be like the caps on our shoelaces, where our shoelaces are our chromosomes, which is like a long string of beads, and the caps are the aglets on our shoelaces. And they get shorter as the shoelaces age. And when they get really short, your shoelace starts to fall apart. Well, so people thought this was the same thing happening with telomeres. But it didn't explain the reproductive cells. And so we discovered this enzyme telomerase, well, actually serendipitously, years before. Carol Greider and Elizabeth Blackburn discovered an activity in this pond scum organism, Tetrahymena, that kind of like did something to lengthen telomeres, but it wasn't. So when Cal Harley started looking at this years later and stumbled upon that paper, he started saying, "I wonder if this all connects. Is there something in human cells that's equivalent to that thing they found in Tetrahymena?"
Right.
That's explaining telomere shortening and the Hayflcik limit. So theories, they're meant to be tested.
Right.
He didn't call it a theory; he called it a hypothesis, which meant he was testing it.
Right.
I just jumped on that bandwagon. But we discovered it. We were able to show that, sure enough, by putting it into human cells in a petri dish, the cells never reached the Hayflcik limit. Every biomarker of aging that we could check, looking at different genes in the cells, we could see that everything about aging that we knew of at the time, we could even imagine, was reversed. It had reversed aging in human cells in a petri dish. First time this had ever happened. People tend to ignore all that data now when they try to market other products, but that's the first time in the history of the planet that anybody had actually reversed aging in a human cell. Later,
and what is that, like 94-ish?
That was actually, because we discovered telomerase in 93, 94, and then the protein component, which I never actually finished talking about. Let me just say really fast, after we discovered the RNA component, we ended up discovering the protein component.
Okay.
And then, about the same time, Elizabeth Blackburn and Carol Greider published that they had discovered the protein component in Tetrahymena, but it was very different.
Was this in 95, like 10 years later? Or?
Yeah, like 95. They had gotten, after the Cal Harley publication, they had gotten back into things.
I was about to say,
They discovered this protein component, but it was very different than the protein component we discovered in humans. So we went and we looked for the protein component in their organism, looked for it in Tetrahymena, and found a very different protein that turned out to be very similar to the human form. And so whatever they discovered is still published, but I don't think it has anything to do with telomerase.
So they didn't actually discover telomerase in 1984. They just kind of thought they did?
Yeah.
Okay.
And the protein component.
Gotcha.
In fact, that's the catalytic, the most important component. That's the thing that controls whether telomerase is on or off or something like that, is the protein component. So that ended up being the critical thing to discover. So we discovered the RNA component of human, the protein component of human, and the protein component of Tetrahymena.
At Geron Corporation
at
around
Geron
94.
Corporation, yeah.
Yep. And you were leading that team.
Yes, I was leading the team. And what we did then was we published a paper where we, in vitro, like in a test tube, we took the protein component and we took the RNA component and we mixed them together and we got full telomerase activity. So we were able to say, you don't need anything else. It's just these two components. That's it.
Right.
What they had discovered in Tetrahymena was something that had some affinity or something like that for the telomerase enzyme, but it didn't play a role in actually the activity. So we had this activity, so I said we put in human cells. We showed that they stopped aging. Their telomeres stopped. Their aging was actually reversed by every method of measurement we could do at the time. Then Walter Funk, who also was one of the people that shared so we got this award for National Inventor of the Year, second place for something to do with the United States Patent Office. They award the best patents every year. So we'd gotten this award. Walter Funk was one of the people that shared that award with me. He then worked with another company to try to grew human skin on the back of a mouse.
Okay.
So now not only could he look at cells they could actually look at human tissue. So he lengthened the telomeres using the telomerase enzyme in that skin and showed that he reversed skin aging. And again,
the human skin on the back of the mouse. And what year was this, approximately?
He published that in 2000.
Okay.
Then later, Dr. Rhonda Pinnell, using whole adult mice. Now, he had to use engineered mice because I mentioned earlier, or at least what you'll see later in our tour, that mice don't actually age like humans. Okay?
Right,
They age from oxidative stress, mitochondrial dysfunction. They have a Hayflcik limit, but their Hayflcik limit isn't abolished by lengthening telomeres. It's only abolished by adding antioxidants. But in order to use mouse as a model of studying human aging, you first had to engineer it so it aged like humans. So Rhonda Pinnell created this mouse that had telomere shortening. He was surprised at how similar they look to humans aging. You know, old mice now look like old humans, whereas a regular old mouse didn't look anything like an old human. But he then fed him a drug that he had designed that would induce telomerase, but only in these mice. It wouldn't have worked in any other mice. It wouldn't have worked in humans. This drug would induce telomerase in these mice, and it lengthened telomeres, and these mice got younger again in every way imaginable. Diane Sawyer did a news story on him, showed pictures. He called it a remarkable reversal of the aging process. Nobody had ever done anything like that before, for real. Of course, now a lot of people claim they're doing it now and forget all about that old data, but it's been reproduced a lot in Spain now. Lab at Maria Blasco's lab in Spain has done a lot of work to show that she can get the same kind of results. The problem why everybody doesn't know is that these are expensive experiments, okay? Especially since they're involving gene therapy. And even though we can put these gene therapies into human cells, it comes at a cost because the gene therapy, the way it delivers the gene to the cell, often causes toxicity to the cells. So it's been pretty much impossible up until recently to actually use gene therapy to deliver telomerase to human cells because deliver telomerase to humans because the delivery method all by itself was toxic enough that it would cause too many bad side effects. But so lately there's now a new way to do it, and that's what we're doing.
Okay, and so, Liz Parrish, I believe it was in October of 2015, she had 2 gene therapies done, and one of those was telomerase. Yeah. Do you know specifically, is that different from what you were describing earlier when we were walking through?
I handed her both those gene therapies in this exact room.
Okay, because I know you guys are friends.
We made them. We gave them to her, and
it just can't be done in the U.S. right now. It would be illegal, which is why she had to go to Colombia.
Here they are, but I don't want to have anything to do with it because if she dies or something like that, I don't want to go to jail. Okay, but I was all for it. Her, if she could find somebody to actually scale it up, because we didn't give her enough, she had to make more of it, and that's called scale up. And somebody had to scale it up, and then some doctor had to treat her, and she found all this. She actually got treated in Colombia.
Right.
I think
the country of Colombia, yeah.
And she didn't die.
I remember when this was all happening. I've been friends with you guys on Facebook, and it was getting pretty testy. All these major scientists were saying, and sorry I did that, but they've shown they're not that smart because most of the credible scientists were telling her not to do this, and she was saying, "Well, I'm going to do it." And
here
it is.
I was not telling her don't do it. I was saying I wouldn't do it.
Right, and I wasn't speaking of you there. It's one thing to say I don't want to do this to myself, but there were so many scientists on the internet who were telling her don't do this, and she was basically saying, "Listen, it's my body." And most of the cryptocurrency people and anti-aging people like myself are more libertarian type people, which means it's my body. I get to choose what I put into it or not. And it's been about 3.5 years now, and she's now making more YouTube videos describing what she's done, and she's very healthy. Her biomarkers have improved since then, and she's documenting things. So
I don't think anybody knew before she did it that she was going to do it. So nobody was telling her don't do it.
Oh, I specifically remember she was announcing that she was going down to do this, and there were people online.
So your memory's better than mine. I was thinking that she didn't say anything. Until
Unless
actually she
there
did.
is sometimes false memories, and I don't think I'm false remembering this. I remember she was announcing she was going to do this, and then people were saying, don't do it, and she was like, well, I'm going to do it.
I don't think she announced that she actually had the ability to do it. I think she was announcing that she wanted to do it, but I don't think she told anybody that she actually had the gene therapy.
Okay.
And actually had a doctor who was going to treat her. And I think that didn't get announced until afterwards.
Okay. I was remembering that she did, but the internet will
we should
clearly
ask her.
remember.
Let's not, she's
Liz, if you're going to watch this,
anybody,
she will remember.
In fact, if you haven't interviewed her yet,
I'm planning to hopefully interview her. Hopefully, Liz, if you're open for that, and I'll reach out to her. I know she's based out of Seattle, but she travels all over the place. So I'd love to have her document that story a little bit more on those details.
Come to RadFest. Okay.
So the problem is, I was traveling through Europe last year, been working jobs in the first 2 years before that, and now, unfortunately, my wife's going to be 8 months pregnant at that period of time, and I want to go.
Well, everybody else should go to RadFest because Liz would be speaking, I would be speaking,
Okay.
Aubrey de Grey would be speaking. It's the best cast of
Am I getting the
people.
sign-off from my wife? Okay, hopefully you don't have a baby while I'm in.
I'll call you if I go into labor.
Okay, all right, I
Okay.
think I'm going to go.
Yeah, good, because it's as far as I'm concerned, RadFest stands for Revolution Against Aging and Death, and it's the best conference there is for anybody that wants to learn everything they can to slow down their aging process and live healthy as long as possible.
Right, and it's in Las Vegas, October 3rd through 6th this year, 2019.
You know better than I do. So but that's a good way to meet her and others.
Yeah.
Where were we?
We're all over the place. I love it. The
Yeah.
stories are kind of... So I guess you were talking... You go ahead.
Well, I know I went back to talk about the fact that we discovered the protein component, but there I changed subjects because I wanted to backtrack, but now I forgot what we were talking about before.
Well, gene therapy, which is I think why Liz kind of came in. So we were definitely talking about that. I don't know if...
Well, gene therapy has been around. We were doing gene therapy 30 years ago.
Okay.
But
You were talking about how it was very expensive and
it's
difficult and toxic to get into the cell. That's I remember.
It's actually wasn't that expensive using certain types of gene therapies.
Okay.
But they were toxic. Okay. And so
Specifically for telomerase.
No, not at all. The telomerase wasn't toxic at all.
Okay.
It was no matter what gene was delivered, there was a toxicity problem because the way the gene therapy inserted the DNA into the cell caused damage to the cell. So no matter what DNA was being delivered, it had cerebral side effects. The big classic study was, a long time ago, bubble boy disease they tried to treat bubble boy disease with a gene therapy, and as a result, it's not like 5 out of the 7 boys that were treated got cancer right away and died of the cancer.
Ah, bummer.
So gene therapy was just bad in the way it delivered. That had nothing to do with telomerase.
Okay.
So we were doing gene therapy for research. It'd be okay if half the cells died from the delivery procedure, as long as we could then look at the survivors. Okay, but that's not okay with a human being. But fortunately, a new gene therapy called AAV, adeno-associated virus, came along. And we jumped on that about 10 years ago and started building gene therapies using this, and we tested it and it worked really well.
When you say we, you mean Sierra Sciences?
Yeah,
okay.
Sierra Sciences. We started working it, we started using it a lot here. And that's when Liz and I started talking about, we should probably start doing a clinical study.
Okay.
And try to see if we can get this actually treated in humans. Because lots of other clinical studies had already gotten started using the same delivery, the AAV delivery method, and no side effects at all. It was working. Lots of gene therapies were suddenly getting approved. There's now 2 gene therapies approved by the FDA that's exactly like our gene therapies, except it's delivering a different gene. There's another one that's been approved in Europe. The problem is these are so expensive. The one that just got approved a few weeks ago, I forget the name of it, it cost $2 million an injection.
Right.
Okay. The one in Europe was even like that too. But there were so few people that would benefit from it that it went out of business because it couldn't. The marketing was bad. Science was excellent. Science was great, but the marketing wasn't a marketable product, and so it failed. I think ours will be a very marketable product because every single person on the planet is suffering from aging. But so Liz and I started working, trying to get funding. Surprisingly, we couldn't find funding. It was tough. This is one of the reasons Liz Parrish decided to treat herself, to make some noise. You know?
Yeah, and that's why I was supporting her as well.
And still,
she's a trendsetter.
Still, the funding didn't come. So Defy Time decided to get on the bandwagon. We started Defy Time. Liz Parrish and me started working together, trying to get something. Still didn't work. Then,
so is Liz Parrish involved financially somewhat with Defy Times? Is she like
she would have been if that had materialized into
okay.
anything. But we then got approached by this company called Libella, Libella.
Okay.
That was just about 2 years ago. So it was actually at RadFest in 2017, where I met with a guy named Jeff Mathis, who was the founder of a company called Libella Gene Therapeutics, and he sold us on the idea, let's all work together. Liz Parrish chose not to work with him. Liz Parrish is pursuing the BioViva angle, and with all my support, stuff like that, she and I are still really good friends. I hope when something actually starts getting off the ground, we can all start working together. But that's what's going on right now is Jeff Mathis's company, Libella Gene Therapeutics, licensed our gene therapy. It's the same gene therapy that Liz Parrish used. Actually, I should say it's been modified a lot, enhanced, improved.
Improved, yeah.
Safety.
It's been 3.5 years.
Even though it's safe, we've improved on safety things. There's a whole bunch of all these.
Has the price come down?
Here. No, their price. There's no price won't come down until it's at least a product, but it's only gone up. This is all the studies here that I'm working on right now, trying to get everything ironed out regarding the clinical study. But Libella has already started doing baseline studies with the first patient, with the idea of treating the first patient next month in June.
In America, or?
It's physically where it would be is undecided, but it is under FDA guidelines and stuff like that with the new RMAT program. RMAT, which allows the choice of what country to do it in is going to be pretty much based on what hospital has everything that is needed and agrees to do it and has doctors that are all in one place and things like that. So we've been looking all over the world. Some of the like the pre-testing has been done in the United States. Some of the post-testing will be done in the United States, but you got to remember that, like Libella is actually owned by several people from all different countries. So, so it's not like we're going outside the country. According to them, we're going outside the country if we did it in the United States.
Right. Yeah.
Okay. So it's like, but it's all a small world. Plus, it's all under the confines of the FDA anyway. Okay, the RMAT. So, I don't know. There's actually it's almost like a debate. Hospitals fighting over who's going to be the one to be able to do the first one. So, but my guess is probably going to be done in New Delhi, India, or Bogota, Colombia, or there's still some other options too.
Interesting. And it's scheduled to be next month in June?
Yeah.
Okay.
And so.
And is there a candidate that's?
Yes.
Okay.
The candidate's already been pre-tested. The hospitals are all.
And this is
prepared.
For telomerase gene therapy?
Yes, this is for telomerase gene therapy.
It's exciting. I didn't know this. I'm glad I'm here. I'm learning this.
Yeah. And it's.
Are you at liberty to say who this?
I thought you didn't know that. I did know that.
I did not know that.
Yeah,
are you at liberty to say who the individual is?
No,
okay.
it's.
When
his
will that
family wants that completely kept quiet. Let's say part of the restrictions are that we have to use somebody suffering from a terminal disease.
Okay, that's great.
It's a safety study. I personally object to the whole idea of taking advantage of people that are dying to do studies on them.
Yeah.
Unless we can cure them.
Right.
I believe that we can cure this guy, and he's suffering from Alzheimer's.
Okay.
Okay. He was diagnosed with Alzheimer's 6 years ago. During the pre-testing, he had no clue what was going on. He's that far gone. But his wife and family were supporting it. Their power of attorney, they're taking over everything. They've got it all going. So I believe that not only will we possibly, because what I did mention before was when Dr. Rhonda Pinto studies with mice, they actually saw a reversal of dementia. Okay.
In the mice.
In the mice.
Yeah.
Which really threw the whole world into a loop.
From gene therapies on the mice?
From
Telomerase?
Except it was a different type of gene therapy. It wasn't AAV. It was that more genetic engineering.
Okay.
To engineer. But the thing is that dementia is often called a loss of memory. But the memory in these mice came back.
It's there. It's just can't get access to it. It's
That's
probably
exactly
the neural
what
connections are died. Yeah.
It's not loss of memory. It's loss of access to that memory.
You ever think about like when you can't think of a memory and then you like think really hard and get it?
Well, we know from studies that you can actually see neurons being formed to connect the dots.
Right.
And so I believe So I believe there's a chance it's going to happen in this first patient.
Okay.
Such a good chance that I can't wait to get it done, mostly for his sake, you know.
And is this just a telomerase gene therapy, or will we be doing other?
This will be just a telomerase gene therapy, but it'll be far enhanced over what Liz Parrish used.
Just an upgraded version of it, basically.
Well, it's an upgraded version, and we're changing a few parameters. We learned a lot from Liz Parrish's treatment because, you know, every time you do something for the first time, you find out, well, maybe next time we should do it a little bit different.
Totally.
Maybe so I can't go into details about that, but it's we've enhanced it in every way imaginable, and so I'm looking forward to actually seeing this happen. But again, we might treat the person and find, okay, well, next time we got to do it.
But that's information as well too. At least you'll learn, right?
I've been through 7 or 8 different clinical studies before, and you learn a lot during those clinical studies. And you can't learn it any way beforehand because humans are very different than other animals, and plus you can't in vitro is very different than doing humans, and so you learn so much, but you get it worked out. And that's
sometimes learning what doesn't work can be the most important.
The good news is I feel like we could possibly do this first patient a great service by bringing him back, but there's a chance he might even pass away before we treat him because he's so far gone. And I hope that doesn't happen. But.
Well, that's really exciting. Do you have any plans yourself to receive that type of treatment at some point or anytime?
Well, I'm not a Liz Parrish.
Okay,
I'll be the first one.
You're a little bit more reserved.
I'm scared.
Scared. Okay.
I mean, look at what happened with Celebrex. Celebrex got approved by the FDA, and still a whole bunch. What did they get? Cancer or something like that from Celebrex? It's like it's got to take a lot of people. Unless I was super desperate. Okay, and right now I'm super healthy, athletic, things like that. I'm doing really well for my age. I don't need it. But if I suddenly start feeling I needed it, I'd be first in line.
What do you think are the most likely negative side effects from it? You know, put the money aside. It's a lot of money. We've discussed that.
In fact,
what's your reservation for doing it then?
Side effects. Well, the side effects wouldn't be from telomerase. The side effects would be from, was the prep.
The procedure, right?
No. The prep. Let's say the scale up. Okay, so Labella is playing some firm to grow the gene therapy in a 2,000-liter bioreactor, stuff like that. Well, they have to purify it, clean it up, and stuff like that. Well, suppose they leave some kind of like toxin still remaining in there, like some kind of like alcohol or some drying agent or something like that. This happens a lot. A lot of times you can order pharmaceuticals and you take them all the time, but then one lot you open it up, you take it, and tastes like formaldehyde or something like that, formaldehyde, and that means that somebody didn't clean it up right. So there's a lot of things that maybe someday we might find maybe 1% of the people have some type of side effect. We'll find out what's causing that side effect. We'll fix that problem. I want to wait till all that's over. Okay,
gotcha.
Unless I got desperate. Okay, there's been times when I've done treatments on myself that I. Nothing like what Liz Parrish has done, but it's something where I thought, I've got a health issue that I think I could benefit from, and so I did something and it fixed that problem.
So to summarize on that topic, you're very confident in the science of the gene therapy, and you're very confident that it's moving forward and improving, and you're actually part of doing that. Yeah. Your main reservation in not doing it is that it's such a complex process. Something could go wrong, and it's not worth the risk since you're healthy.
Now there are a lot of rumors going around that telomerase can do things like cause cancer.
People have been saying that for years, though, and you've mentioned that many times.
In my book and videos, I have addressed that problem. There's no data supporting it whatsoever. It's just hearsay, just a rumor. And it's actually mostly spread by people that don't have a background in cancer. And I've got a strong background in cancer. In fact, the National Inventor of the Year award that I got in 1997 was more for my cancer research than anything else. But it's like there's no way. What I can say without a doubt is that telomerase is going to decrease the risk of cancer, not increase the risk of cancer. And that's been, like in my second book, the book titled Telomere Lengthening, I have a whole chapter on that where I actually go through all the data. And I always say you can't just have scientific peer-reviewed data showing something's true or something's not true. You have to have data that survives what's called a meta-analysis.
Yeah.
Okay, and so in this book I've gone through the meta-analysis, looked at maybe 100 or such studies, and showed that 90% of them say one thing, 10% say the exact opposite, and then when I look closely at those 10%, I find that they're very flawed in terms of the science. They've totally misinterpreted their own data.
Right.
So it's like I believe there's no way telomerase is going to cause cancer. I don't believe it's going to cause any other kind of problems. So that's why, like, if I thought telomerase could cause cancer, I wouldn't be taking TA65, I wouldn't be taking isogenesis, and I wouldn't be taking TAM818. Those all induce telomerase inside my cells, just not as much as the gene therapy does. Inside
your stem cells, right?
No, all the cells.
All the cells.
Oh, yes. A lot of people are making this big deal about stem cells, but it's really all the cells. So the truth of the matter is stem cells have become a catchphrase. Every cell that becomes another cell is a stem cell.
Okay.
We are just loaded with stem cells, but we need to lengthen telomeres in all our cells, not just stem cells.
So you're basically saying what scientists call differentiated cells are also stem cells? Is that what you just said?
Not terminally differentiated. There's undifferentiated, then there's differentiated, then there's terminally differentiated. So terminally differentiated cells, they aren't going to become something else. Okay, but there are cells all through the whole growth of things. They become something, then they become something else, then they become something else.
They evolve.
Yeah, well, not evolve. Evolve would be a whole different subject, but they transform.
Transform is a better word.
Transform is actually the word used for cancer.
You described it. We don't need to use a word like evolve or transform.
Semantics is not an important part here.
While we're talking about stem cells, I don't know if you remember this or know this, but I think it was and we traveled so much last year. I think it was in November. I just messaged you on Facebook and told you, hey, I'm looking into you doing the umbilical cord stem cells.
Can I ask, I got to go to the restroom.
Yeah, of course. Yep.
All
right, we had a quick restroom break, and we're going to hop right back in. We left off on stem cells, right?
Yep.
So just a quick disclaimer on my YouTube channel. I've been documenting, and I need to do my 5-month update. I would have done it today if we didn't drive up here. A little over 5 months ago, I went down to Mexico to Dream Body Clinic, and I had umbilical cord-derived mesenchymal or MSC medicinal signaling cells injected into me, about 300 million. And I know that I've gotten good results from these. It's beyond placebo. I know about placebo. It was basically for my right ankle that I sprained, 3rd-degree ankle sprain. I don't know if you know much about ankle sprains, but
an ultramarathon runner, not knowing about ankle sprains?
Okay, so you know 3rd degree is like really bad, black and blue. And you're 20 years old. I've been having ankle sprains my entire life, but they were all 1st and 2nd degree. As a stupid 20-year-old, I was just like, oh, this one's a little worse, I'll be fine. Well, it just never got better. And so by the time I was 33 last year, I was like, I got to do something about this. So the injections, along with PRP and some calcium glutamate, also into my right knee and right shoulder for dodgeball and baseball, it's gotten tremendously better. I'd say about 80% better. So I'll do an update on my channel about this with more detail, but just that's basically it for me.
I'm a super believer in stem cells.
Okay.
In fact, all different kinds of stem cells work in many different ways. The problem with stem cells is that there's a lot of charlatans out there that just abuse the privilege. They pretend to know what they're doing, and they will inject you with water telling you that they're stem cells, and they're not really. So it's like anytime you have some really great product that works, there's going to be people that are going to try to rip people off to make money off of it. But I know some of the top stem cell doctors in the world, and this is a really great stuff. They're all different levels, from induced pluripotent stem cells to umbilical cord stem cells to fetal stem cells to I'm going blank. Hematopoietic stem cells, mesenchymal stem cells. They all have their pros and cons, but I'm pretty good at spotting a charlatan as soon as somebody starts talking about stem cells and they start saying things that are not true,
right?
Stuff like that. But me and my scientists here have published a lot of papers on stem cells, mostly in the area of telomere lengths and stem cells and stuff. There's a lot of myths about stem cells. A lot of people think stem cells have telomerase produced in all their cells and their telomeres don't shorten. That's not true at all. Stem cells, when they're induced to grow really fast in a petri dish, they will tend to produce a little bit of telomerase, but it's more of a leakage effect, because every time the cells divide, the DNA has to be duplicated, and for a short period of time there'll be an unprotected telomerase gene that gets a little bit of leaky expression before the repressor shuts it off. The people will talk about in publications about stem cells having telomerase, but they'll never talk about how much. And if the paper looks to see how much, they suddenly realize it's not very much, it's not worth publishing. We, in our studies here, looking at stem cells, the highest we've ever seen in telomerase activity is about 8-fold below what it takes to prevent telomere shortening. And we're really surprised, even at only 8-fold lower, we don't even see an extension of the Hayflcik limit when we take stem cells and culture them. But the only true stem cells that actually do produce telomerase enough to actually affect the stem cell, and actually they're immortal, are human embryonic stem cells and induced pluripotent stem cells. All the rest of them, they have the low levels of telomerase, but there's no data showing that they actually have extended telomere length. Now, let me not stop there, because there are some possible exceptions to this rule, and that's when immune cells start producing a lot of B cells and T cells. The numbers can't be explained except to assume that there's some telomerase being produced and the rate of telomere shortening is decreased. But nobody's ever actually shown the data.
Okay.
It's just common sense tells me, well, there must be something going on, because they're exceeding what is the Hayflcik limit. But I believe it's because these cells are dividing so rapidly, there's just a lot of leakage of telomerase activity. That's the only time you ever see it.
When you say leakage of telomerase activity, I think I know what you're talking about, but can you describe that a little bit?
Leakage of telomerase expression.
Okay.
So the gene inside of our cells, every cell of our body has the telomerase gene, but in 99.99% of our cells, it's repressed.
Yeah.
It's repressed by a protein that binds to the gene and shuts it off. Well, when a cell divides and it makes a new copy of the telomerase gene, there's a short period of time where that gene the new gene doesn't have the repressor. The repressor has to find that gene. Remember, repressors are floating around inside the cells. They have to find that gene and shut it off. So until that repressor finds it, it shuts it off, there will be a little bit of telomerase expression produced. And I think that's why we see that rapidly dividing stem cells will have this phenomenon. What's her name? I'm forgetting a scientist at University of Southern California did some studies on stem cells and found out that if she induced stem cells to grow really fast, she could see telomerase activity. Of course, she never measured how much telomerase activity, but she would detect telomerase activity. She'd take the mitogen, the thing that caused the cells to start dividing, she'd take it away, telomerase would disappear. She'd treat them again, telomerase would go up. She'd take it away, again it went down. But always the third time, it wouldn't induce any telomerase. So one day I was talking to her and I said, well, did the cells grow? Did the cells grow just as fast as they were? And she said, yeah, that's the other weird thing. The cells didn't grow as fast either. Okay, so it's saying that,
right,
after 3 times of inducing
where there's
these
smoke,
cells,
there's
they
fire.
lost the ability to, they lost the ability to actually divide fast. Why? Well, who knows? But But it's the only reason why stem cells ever produce telomerase, except for the human embryonic stem cells and induced pluripotent stem cells, is because of what I call leakage expression, leakage or leaking expression.
Okay. That's really helpful. And then I'm on a Stem Cell 101 group on Facebook. Shout out to anybody who's watching there who's on that. So I learn a lot from people. There's all sorts of people, from literally people who just heard about stem cells an hour ago and their mom invited them, to doctors who are experts and inject people, have their own clinics. So there's all sorts of people on there. I learn a lot. And also from doing my YouTube channel, I've had people reach out to me and they've taught me certain things, and they actually sent me that God Cells documentary that I told you about. Eric Merola, the director, has agreed to do an interview similar to this down in Santa Monica. He's traveling outside the country right now, so I hope to interview him and learn more. But I've been learning more about fetal stem cells in this one company in Kiev, Ukraine, called EmCell. And so we discussed this a little bit off camera, but I'm just super fascinated about that. I personally made the assumption that embryonic pluripotent stem cells 5 days or early on were just tumorigenic, cancerogenic, really bad. And then I came across this documentary. And a quick backstory, I'd actually seen 3 of Eric's other documentaries in the past, dating back to 2010, that I thought were really good. So he had already built up a little bit of credibility with me. And so I'm kind of just in that investigative process right now, but really excited from... Hopefully you can watch that documentary.
Yeah,
and
I'm looking forward to it.
But without watching the documentary or his presentation, I think you just stated a number of things on stem cells. Anything else you want to share just regarding stem cells in general, or fetal or embryonic or whatever? I don't know. Anything else you wanted to say on that?
Well, all I can repeat myself is just be wary. There's a lot of charlatans out there, and it's nice to know stem cells as much as I do, because I know when somebody's not telling the truth.
Right.
Yeah, that's all I can say. But there are some really legitimate places. I wish I could give you a list of the doctors that I think are the best in the world and stuff like that, but I don't market.
That's one of the things that we try to do in the Stem Cell 101 group. But the difficulty with this is there's so many people all over the country and then the world. So location's big, and then there's money. And then there's insurance. It's not just as easy as this is the best clinic. It is kind of more like, well, how much money do you have?
When I say the best doctors, I mean the doctors that I can go talk to.
Okay.
That know what's going on. Okay.
Gotcha.
And so some of these doctors, they insurance won't cover what they do and things that they're, hundreds, not hundreds, but tens of thousands of dollars sometimes to get treated. But they're legitimate and they know what they're talking about. And I respect them, and some of these speak at conferences a lot, and I can tell listening to talk that they're legit, but I can hear other people talk and I know they're not legit. But I don't know. You were saying you have some list or something like that.
Well, what I was saying is that
the list and nobody knows that it was me that added it.
What I was saying is that we're trying to put together, and everybody has their own different lists, but in the group, people have tried to put together like different lists of, hey, these are definitely scams, these ones are definitely legit, but they're more expensive, and then there's also, it's such an evolved science from where it was 10, 20 years ago, but it's still in the early stages.
None of the different types of stem cells I would call scams. They all have their benefits.
Right.
Including PRP and exosomes and things like that. It's the doctors. Some of the doctors are the scammers.
Yeah.
And so it's like figuring out which those ones are. But
and even with some of the well-intentioned doctors, sometimes we just still don't know what the best protocol is for a specific condition. So are you trying to treat COPD or autism or Parkinson's or a musculoskeletal condition like my ankle? They all have different protocols, and obviously you want to go to the most ethical, intelligent, experienced doctor to get those answers. But that's kind of what I was getting more towards with that.
Something else to keep in mind is that mesenchymal stem cells, for instance, won't do everything. Hematopoietic stem cells won't do everything. But you can get a lot done by doing both. Okay? And so it's like, I can't remember exactly what the limits are on each of those, but I do know that they do have limits, each of them. But because really, if you want a stem cell that does everything, you're going to have to go to the human embryonic stem cell. And a lot of times they call them pluripotent stem cells, but they really aren't pluripotent. They're near pluripotent. The only true pluripotent stem cells are the human embryonic stem cells and the induced pluripotent stem cells.
Yeah, which are like 5 days after conception, the super early stage
induced
one.
pluripotent stem cells are where you take skin cells and turn them into stem cells.
Okay.
Okay, so those are not, they're the actual solution to the coethics issues of human embryonic stem cells.
Yeah, the embryonic pluripotent ones isn't that phrase normally referred to like 5 days after conception, the embryonic pluripotent? Or is that
I don't get into that level. What I can tell you is that the human embryonic stem cells are essentially the primordial germ cell. They're the cells in that embryo that are immortal.
Right.
Okay. So what stage they get in? I just remember when I was at Geron Corporation and we were working with Johns Hopkins and the University of Wisconsin, Madison, with all this stuff. It was pretty hard to identify the cells, but they had to come from aborted fetuses. Figuring out what day it was, and stuff like that. That's not something I can remember.
Okay. And then, my stem cell research in the last, year and a half or so has led me down a rabbit hole that's just never ending, and it's always fascinating. And I discovered this company, Chimera Labs, a couple months ago. They are producing exosomes from mesenchymal stem cells, and then they sell those to, doctors who can inject those into people. And now there's a group on Facebook. It's exosomes, and it's people who've done them. And now I've talked to some of those people, and it is exciting. It's hard to, there's not enough studies done on this stuff, clinical trials. So you're going a lot on anecdotal information right now. But
there might not be clinical, but there's a lot of preclinical studies on these things that show they're really, really powerful. So they have a lot of promise.
I can speak just personally, the anecdotal information that I've heard from actually talking to people on the phone and communicating with them on Facebook groups, people who have actually had these things put into their body, 90% has been pretty phenomenal, just their results. And I talked to a few people who had also had multiple stem cell procedures before, like umbilical injections and also autologous and bone marrow. One lady I talked to had all three. All those helped her chronic condition for about 2 weeks, and then that came back. When I talked to her a month ago, she had exosomes injected 2 months before that, and she was still, all her chronic condition symptoms were just completely gone still. In other words, better than...
There has to be kind of, I don't know if the right word is disclaimer, but I've been through enough clinical studies to know that I have just seen too many people in the placebo group get cured.
But these are chronic, like really, this lady's, hers is like, I know the placebo effect is super powerful.
Things like that. So I don't know why you were going to say chronic, but people's cancer would disappear when they were in the placebo group.
Placebo is insanely powerful. So can we talk about that for a few minutes? Because
placebo effects are something that are very, very powerful, and you always have to remember that. But that doesn't mean that what you're saying isn't true.
Right.
It's just that I've just been surprised so many times with the power of placebo effects.
From my research, and Bruce Lipton is a guy I've followed for many years. I don't know if you've heard of him, but...
Oh, yeah.
Okay. I've read all 3 of his books and watched way too many hours of his lectures on YouTube over the years, but he says that it's been documented in all the big alphabet soup, organizations in the U.S., like the American Cancer Society and so on and so forth. They all admit that at least a third of all healing in the U.S. in the world is done by the placebo effect. So that's just the data that I've kind of heard and researched. Do you have any percentage?
I don't know if I believe Bruce Lipton.
Okay.
But I don't disbelieve him.
Okay.
I mean, I don't know what the magnitude is.
Right.
Some of these supplements, for instance, that even I'm part inventor of, and stuff like that, I have seen just people go bananas over saying, "Look at all the things it's doing for me."
Right.
And I think, well, they weren't designed to do those. I think you've misunderstood something. And it's like, so I've just seen it. It's like, what do you do when somebody starts claiming that something that they're taking cause their hair to start growing,
right?
When there's no reason why it should be making their hair. But it's like, it's you just, how do you prove that it's not happening? It's
totally. But like most people will just cut it off. Oh, it's placebo, and they move on. But I've researched placebo pretty decently, and like tried to understand what it is, and really your pituitary gland emits a bunch of different hormones, right? And so it's not just that, it's other things. Your consciousness, if you're more happy and excited, you can produce a bunch of hormones and chemicals that can have positive effects.
Exactly one of the explanations as to why there are placebo effects.
Yeah. So, well, one question I wanted to ask you earlier is about, we talked about aging in humans, and we talked about aging, I think, briefly about like in dogs and stuff, but from my research, flounders, crocodiles, definitely giant tortoises, lobsters, and some other animals, they're all from the sea, the ones that I mentioned, they just don't seem to age like humans do, and their telomeres seem to stay longer.
I hadn't heard about flounders and crocodiles, but I know about the lobsters and the tortoises.
Yeah. Another one that I saw a documentary on back in 2012 was this Japanese scientist who'd been studying jellyfish for 30 years in his lab.
Jellyfish are an entirely different animal.
Right. They don't have a brain, and they're basically asexual.
They're a colony.
Okay.
Jellyfish is, you can take a jellyfish, you can break it into a whole bunch of pieces, and all those pieces will grow back into jellyfishes.
Right.
They're a colony of cells. They're not like humans.
Right.
The same argument you can do about trees. Some of these trees are 2,000 plus years old,
right,
but they only have one little branch that's alive. The rest of it's dead as a doorknob. Okay, and it's like, I don't want to be considered alive if only my little finger's alive. Yeah,
because some of your cells, like your fingernails, keep growing after you're dead. Like that's no good. You're dead.
But that's not life. Life means live cells, and you don't need fingernails. Can still grow even with. I would imagine the cells don't have to be alive. I'm just realizing I'm not an expert on how nails grow. So
no worries, yeah.
But it's the plant, the trees, the old trees, they have cells that are alive in one small little branch. And that's just not alive like jellyfish and trees, they're just not similar enough to humans and other mammals to really say that their aging has anything to do with it.
So that was kind of my question. Like, I guess what my question really is there anything useful that you think that we can learn from these type of animals who seem to age more gracefully or not show the signs of aging like these, that we can extrapolate into humans?
I think there's a lot we can learn.
Okay.
I don't know it yet, though.
Yeah.
But I do know that the studies have shown that the tortoises, the lobsters, the clams, humpback whales, these animals have telomerase produced in all their cells. They have no telomere shortening. They also, but so do mice. Mice have telomerase in all their cells, and they don't have any telomere shortenings, but they still get sicker than hell from other things, and it's oxidative stress and mitochondrial dysfunction. Why is it that the tortoises and the lobsters, they also don't suffer from mitochondrial dysfunction and oxidative stress? Okay, that book on top of that pile right there has a picture right on the front showing that the level of antioxidants in, it's Richard Cutler, who's the author of that book, shows that different animals have different levels of natural antioxidants. Mice have the lowest on that list. Humans have 100 times that. Okay, and the other animals are on that same scale. So I haven't looked, but I bet lobsters, and if they're on that list, lobsters and tortoises might be up there too. And so they don't have an oxidative stress problem like mice do. And maybe that's why they live so long. But they also have no telomere shortening, and that's another reason why they live long.
And is that because their telomerase is more active, or
their telomerase isn't more active? It's just more present.
Okay.
Okay. So their cells are producing telomerase, whereas in our cells we don't. Okay.
They're producing them like in all their cells, whereas us, they're just in their stem cells, basically.
Well, they're not even in just the stem cells.
Okay.
The only place you can find telomerase in humans is the primordial germ cells.
Okay.
Which are the cells that are used to produce the egg and the sperm.
And when you say we find them, you mean like where they're actually turned on? They are in the other cells, they're just not turned on.
The gene is turned on in every. The gene is present in every cell.
Right.
It's just that the gene is turned on.
This is more for the audience. I knew what you were saying, but this stuff is confusing, and I want people to understand, like, the devil's in the details with a lot of this stuff.
Genes get turned on and off like light switches. Lights get turned on. It's more like a dimmer switch.
So if you don't know about epigenetics, just when this is over, Google, YouTube, epigenetics. You got to learn about that. You can turn cell genes on and off. Well, super fascinating. You mentioned mitochondria very briefly. It's something that I've been researching a lot more personally within the last 6 months, from doing the stem cell injections and kind of putting that on the internet. A gentleman reached out to me on LinkedIn in December. We've been having conversations since then. He was running a mitochondria company. He's been finding out some incredible stuff. He wants me to keep it private for now. Hopefully I can talk about that stuff later. But the things that he has told me about mitochondria has really changed my thought process on how important it is. Can you just tell me about how important you believe mitochondria is for just aging and health in general in humans?
Well, I believe it's important. I have a hard time really grasping how important it is. I do everything I can to protect my mitochondria, but I know that most of the data is mouse data. Okay, and so it's hard to find data on human mitochondria, and it's frustrating that there isn't more data on it. And it might be that humans really don't have that big a mitochondria dysfunction problem. Now, it's also, there's a lot of studies that show that aging causes damage to mitochondria, and then there's also data saying that damage to mitochondria causes aging.
Right, chicken or the egg problem,
yeah,
right?
So there's all that big thing going on too. Now, Dr. Rhonda Pinnell, for instance, so after he did his big study to show age reversal in mice, he also did this other study. They looked at mitochondria dysfunction with keeping telomeres long. And what do you know? The mitochondria dysfunction was decreased tremendously just by keeping telomeres. So there might be some correlation between mitochondria and telomeres. But there's also these people that say that telomerase actually is inside mitochondria and functions there. I haven't found anything that I actually believe yet, but I'm not ruling it out. But I can't understand what role telomerase would have in mitochondria, since mitochondria DNA is circular and has no telomeres. So there's still a big question. I'm good friends with a lot of really strong mitochondria believers, and including some scientists that work here actually are very big into mitochondria. But most of the data is on mice, not humans.
Yeah, speaking of mice and mitochondria, I'd be remiss if I didn't mention one of his colleagues and friends is this gentleman who I've connected with on LinkedIn, Keshav Singh, Dr. Keshav Singh. He's at University of Alabama, Birmingham. He's a scientist. And a few years ago, they used mitochondria. They gene edited the mitochondria in a mouse to make it old. And when they say old, it's fur and skin got really old.
But what did they do to the mitochondria that caused that? It's like
mitochondria,
there's only a few genes involved.
I'll link the article on this YouTube channel so you guys can check that out to just read the article. And that show The Doctors that's on, I don't know if you've heard of it. There's a show called The Doctors.
Watched TV.
Yeah, they did a little piece on it. I don't watch TV, but it pops up on the internet, and they did a little piece on it a few years ago. But essentially, they gene edited it. And if I'm misspeaking or saying anything, I'll link the article, and you can see exactly what they did. Essentially, this mouse got older. They made it older by making the mitochondria gene edited old. And then they reversed it back and made the mitochondria young, and all the biomarkers of it, not all the biomarkers, but particularly the skin and the fur got young again. Okay. So I found that fascinating.
I don't find that. I find that completely expected.
Okay.
Given that, I was asking what did they do to make the mitochondria older, but there are definitely correlations between certain deletions in the mitochondria DNA that occur with age.
Okay. They
might have created these mutations, which made the mitochondria unhealthy. And if they undid those mutations by some type of gene editing or something like that, they would almost certainly have reversed.
Yeah, the most exciting part is the last part, where they made it younger again. Yeah. It's not too great that they made it old. I don't want to go around.
They younger. Okay. They made the hair color come back.
Right.
Something like that.
Sometimes that's a good point.
That has nothing to do with aging, and that's a big problem in the whole industry. It's like people keep talking about age reversal when it's actually just health changes.
That's a really good point, because that's something when I first kind of read this article and watched a little 3-minute video that I pointed out. It's like, well, the hair grew back and got darker, And it was also the skin elasticity as well too. And you could see these things, and they measured it with biomarkers. Again, I'll link it in there. Yeah. But even if we could do that, like, I'd love to have better skin, and obviously I'm balding, so I'd love to have that back. That would be great.
I agree, 100%. And that's why I'm glad so many people are doing all this kind of stuff. But still, none of that's going to make anybody live beyond 125 years, live even healthy anywhere near 125 years. And that's not going to come from the mitochondria problems and stuff like that, because telomeres are shortening no matter what. If you keep mitochondria healthy, the telomeres are still shortening by a very well-defined mechanism that can't be stopped except by inducing telomerase. So I'm all for everything we can do, and I take 100 supplements a day to help in every way possible. But I know that none of that's going to get me to live beyond that theoretical maximum, 125 years, that telomeres control. And that's only for the really lucky people that have the perfect genetics and the perfect diets and lifestyle and stuff like that, and avoid being run over by buses and stuff like that. They're the ones that might live to be 125 years. But the rest of us, we all have these lifestyle problems and genetic problems that are going to limit us a lot slower. I think doing everything possible, mitochondria, everything else can help, and oxidative stress can help us get older, but nothing's going to get us past that 125 unless we solve the telomere shortening problem.
Okay. And so, Aubrey de Grey has coined the human escape longevity velocity.
I think I coined that,
butchered that.
I know he uses it.
I actually don't know if he's coined that, so that's a good point, but he uses it a lot. I think he did coin that, but maybe I could be wrong on that.
He would be the one to do it.
If you don't know what that is, it's basically when we are adding more age from our scientific research onto the potential lifespan of humans, then time is passing. So in other words, if we're adding 1.1 years of life onto human potentially every year, then we've reached escape human escape velocity.
I know there's like what is it? Terry Grossman. He coined the phrase "live long enough to live forever."
Right.
And so even in the Immortalist, he's in the Immortalist. He talks about the bridges and the escape velocity and things like that. But I'm wondering, was it Ray Kurzweil that actually coined the phrase?
I think it was Aubrey de Grey that coined that phrase. But again, we'll have the interwebs decide. I'm sure people comment below, or
I can tell you about the science. I can't tell you who did it, though.
And honestly, it doesn't even really matter. But it's a great phrase, and it's important for people to understand, because people are like, oh, how are we going to live this long? It's like, well, we just have to reach human escape velocity, right, where we're adding more years.
Hopefully we already have.
And so with that being said...
You're more likely than me.
You're doing well. I think you have a chance, a good chance.
Yeah, me too. That's why I'm here.
So leading into, I guess, my next question, do you think that humans, or do you think this question is just too hard to answer right now? Do you think that humans can end up living like hundreds or thousands of years, or is that just too difficult to answer at this point in time?
Well, the way you phrased it, absolutely yes. I think they can.
Right.
Okay. I don't know if we're actually going to succeed, but I think it's possible. That's why I'm doing my research.
Yeah.
I thought you were going to ask, is it going to cause more problems than it's
Oh, I'm way past all that. Yeah. If you want to go down that philosophical rabbit hole.
My book, if anybody wants to read a book, I can.
Yeah.
In 100 years from now, when we've cured aging and we have all the problems that everybody's worried about, everybody's going to say, well, the problems aren't as bad as they were before we cured aging.
Yeah.
Let's stick with it.
And let's actually address that real point. So 2 things. Number 1, if it happens, it happens. Scientists are going to keep progressing.
Everything happens that can happen.
Right. Everything, exactly. You just said it perfectly. So if it happens, it's going to happen. It will cause other problems on the planet, right? There's no doubt about that. But it's going to happen. And so we're then just going to have to deal with those problems. And people, I've already played this out in my head in so many different scenarios of what's most likely to happen. And I'm sure you've done that probably even more than me. And it will just be a different world.
Well, in the late 80s, early 90s, I think that's when it was, when people started hearing about this thing called the World Wide Web. Everybody started saying, no way, we can't, this would be way too, now we can't live without it.
Right.
Okay, so humans adapt to whatever changes were going to happen. Humans adapt. Look at it in the different politics in the different countries.
Oh my goodness.
Lifestyles, they all seem to be okay with it. We could never tolerate lifestyles in some other countries. They think the same in reverse. So people adapt somehow to whatever the lifestyle environment is, and that's going to happen when we cure aging.
That's what I've learned about humans just from the past few years that I've really appreciated, is that we really are the most adaptable species on the planet. That's why we're dominating everything. That's why you see, big tall buildings and everything and planes, because we've adapted. So we're very well adaptable creatures, much more so than other animals.
It makes me think about, I'm often asked, why am I so obsessed with curing aging? Our adaptability makes us like so many great things are going to happen in the future. What people keep saying, asking, am I afraid of dying? And I always say, no, I'm not afraid of dying. I'm afraid of missing out.
Yeah.
I think a lot of great things are going to happen. And I have when I speak to some audiences, I always show this great slide of a scene from the movie First Contact with Star Trek. And it's got what's his name? James Cromwell playing Zephyrin Cochrane, the guy who invents warp drive, shaking hands with a Vulcan. It was first contact, actually meeting somebody. And the Vulcans came to Earth because they realized that Zephyrin Cochrane had exceeded the speed of light. And so I show this slide, and I show that here they are shaking hands, and I say, the reason why I'm obsessed with curing aging is because when this happens, I want to be there.
Heck yeah.
I fade into the picture holding, like doing a three-way handshake. In fact, I should show that. I should bring it up and show it to you.
If I definitely do want to see that, and I can maybe even add it in at the end as a picture. But yeah, that's super cool. And basically what you're saying with that story is that science is going to keep progressing. Who knows what's going to happen in the future, and that you want to be around to see that. And that's generally my answer as well too. I just want to stay young and healthy, and if I ever want it in my life, then I can choose to do that at any point like people want to. But you got it pulling up here?
I think I do. Let me just see. This might be a prior one. Let me go to something later. I know I've given a few presentations here. We running out of time. Is that what she's doing now?
Yeah, I think the...
Let's see. Let me find this really fast. Reno presentation 5/10/19. That should be it. First of all, here's our new logo.
Oh, can you show that? Is that cool?
Yeah. This is
I like it. The jeans and the time and the clock.
Well,
I think you got to pull it over this. Can I?
Just as long as we don't unplug anything.
Yeah. Where is it, Lauren? Is it in? That's super cool. So that's time, jeans.
It's an hourglass. It's an hourglass backward in time.
That's awesome.
The hourglass is made out of the DNA. But let me find this other thing I was just telling you about.
Let me check real quick to see any final questions that I want to get in while you're doing that. Oh, I know. While you're looking for that, so we've talked about stem cells and other stuff. What is your just general, thoughts that you can share? Okay, awesome, you found it.
Okay, so I would show this, and I'll say, people are always asking me, why am I so obsessed with curing aging? Am I afraid of dying? And I say, no, I'm not afraid of dying. I'm afraid of missing out. This is, a lot of great things are going to happen in the future, and I'm all excited about it, the science and the medicine especially. But this is a scene from Star Trek First Contact. James Cromwell shaking hands with a Vulcan. James Cromwell is playing Zephyrin Cochrane, the guy in the Star Trek series that invented warp drive.
Yeah.
And then I just go, when this actually happens, I want to be there.
There you are. A little fist bump.
Yeah, this is exactly why I'm doing everything, because I don't want to miss out on all these great things that are going to happen in the future.
Well, then the other thing is too, people, you're like, do you fear death? And I really don't fear death either. And people find that surprising because I'm so much into the anti-aging, the curing thing. I think death is going to be a lot like it was before you were born. It's just nothingness. So why would you fear that?
If I feared death, I wouldn't be water skiing at 80 plus miles per hour. I mean, I've got this finger here this damaged finger because I went, a few months ago, I went snowshoeing. I ran to the top of the mountain here and then ran back down. And I mean, this is like, you run downhill on snowshoes, you are flying all over the place, crashing head first. You know, when I got done, I was surprised the only damage I had was my little finger. I could have killed myself. But
Did you break it, I assume?
I broke the extensor tendon that's on top. So I got what's called a mallet finger, where all of a sudden this joint bent down because the tendon on top didn't work, and now all of a sudden this one was bending, so it was like a permanent bend. I've had this now on for 10 weeks. I'm taking it off on Monday.
There we go.
I'm hoping my fingers.
You never knew how much you needed that pinky until you had to.
You can't type.
Right.
As soon as I bent, I lost the ability to type with my left hand. Stuff. But that was all. I do nuts, crazy things all the time. I risk my life all the time because I'm not worried, fear of dying at all.
So we got to talk about, speaking of that, your ultra marathon running. Can you just, I know that you do that because you believe it's healthy for longevity, but you also have said many times you have to enjoy what you're doing. Yeah. It's really important. I play a lot of basketball and dodgeball, and I do yoga as well, and I enjoy doing those things, and I believe they're helping me.
I'm not going to say that ultra marathon running is good for you. I'm going to say doing it the right way is good for you. But you don't have to run an ultra marathon to get good health. You can run short distances. Like if you run 3 hours a week, that's probably really great for you. In fact, there's a lot of studies saying that's the optimum amount of running to do.
Right.
But I say that somehow you have to motivate yourself to do that. Okay, so you have to set goals, and I always believe in setting big goals. And what turns you on? What's exciting to you? Well, being able to, I've known my whole life, when I look at a mountain, I want to know what's on the other side. I want to know what's up there. Okay, so backpacking, I used to go backpacking, and it used to drive me nuts because everybody was so slow. There were times when I went backpacking, I'd run up ahead, got to the top, drop off my pack, ran back down, carried their packs up. You know, it's like, because I just liked it. I had fun. And so I'm an ultra marathon runner because of the adventure, not because of the health. And as a result, the adventure, being able to, if I didn't train all the time, I could never do these ultra marathon runs.
Right.
So the motivation to train comes from the adventure, but also the training keeps me healthy. But I do believe that a lot of runners are doing themselves an injustice by pushing it too hard. I believe
pushing themselves, like throwing up and like injuring themselves.
Yeah,
it's like not good.
You got to keep it fun. You already alluded to that.
Well, I've had the pleasure of listening to many of your lectures and interviews on YouTube over the years, so I've heard you say these things, and it makes sense to me.
I'm a big believer is you go out and exercise every day, and I believe running every day is not bad for you. There's a lot of people say you need to take a break. There's no data saying that.
There's this guy, David Goggins. I don't know if you've heard.
David and I are good friends.
Okay.
Yeah.
So he's been on
super. He's amazing.
He's been on Joe Rogan twice.
Really?
Yeah, and they're phenomenal interviews.
I've known him before he was famous. David.
Okay. Lauren and I, my wife's behind the camera. We've listened. It's one of those things where I'm like, all right, Lauren, you got to listen to this one because I'll do this for maybe every 20 or so interviews I listen to, and when you listen to that interview with him on Joe Rogan, you just want to go like run over a mountain. That guy is infectious with his energy and his passion and his story. He wrote a book now that I want to read the book.
What's it called?
I can't remember what it's called, but just Google David Goggins' book.
I've got the book. I just can't remember the name of it.
I've heard really good things about it. It's on my list.
I knew him. I ran with him in some races, and we became good friends, I want to say, in the 1990s.
Oh, really? You've known him that long?
Yeah. And I remember.
So he must have been in like his 20s back, or maybe even early 20s.
He was a young guy, but he was just recovering from his cancer
military
or something. His military. I know he was
heart. He had a heart problem. They basically said he was going to die.
But he was like so enthusiastic and stuff like that. Yeah, he's like super powerful. Plus, he also used to be extremely out of shape.
Right. His story is incredible. David Goggins, Joe Rogan, YouTube, type it in. I'll even put in a link below if you guys want. They're phenomenal interviews. But you and him are the two closest storytellers or like people I've heard talk about the ultra marathon running. And man, it's up here.
I've never seen David Goggins exhausted and on his knees throwing up. He keeps it fun. He's he has a blast out of it. I think he's going to live to be 150.
And and he's changed my perception on what's healthy for the body and not. And you just nailed it. He's enjoying what he's doing.
Yeah.
He's even talking about like, I stretch 2 hours every day. And I heard that, I was like, what? But he's stretching while he's like watching TV or video. I watch videos all the time, so I can easily do that stuff while I'm laying around the house doing whatever. And I've started doing it more, and I've seen it improve my fitness as well.
Unfortunately, there's those runners that just kill themselves every time they go out running. They seem obsessed. I know a lot of these really famous ultramarathon runners that were just super spectacular, but now they can barely walk around. They look like they're 10 years older than they should be.
Right.
And I think they did what they felt like doing, but they were more into the glory of winning than they were into just having a good time.
They're stressing themselves out. Yeah. So we got to wind down, but there's a few things I have to ask you before we go. So just lifestyle stuff in general. Personally, I've been doing, and my wife been doing a lot more intermittent fasting the last few years, and it's dramatically improved my health personally. I didn't think I had 20 pounds to lose, but I did apparently, and had to buy new clothes, but I feel great. I feel younger, more energy. What are you talked about you take like 100 pills a day, and maybe for the next interview we can get into details on that, but if you had to summarize lifestyle things that people can do right now to extend their life, and preferably things that don't cost a lot of money. So maybe let's stay away from, we've already talked about TAM 818 and TA65, just everyday things that people can do, diet, exercise, fasting. What are the things you recommend?
Well, first of all, I probably don't take 100 supplements a day.
That's yeah.
I have a lot of people that I really admire about their knowledge and stuff like that. And so, like, there's some books, and one of the books I mentioned was the Kaufman Protocol.
Okay.
It's a brand new book written by Dr. Sandra Kaufman. This is probably the best book ever written on supplements. It not only tells you what supplements to take, it tells you why to take them, what they do, everything. There's no fluff. One of the things I hate about books like that is it'll be filled with testimonials, case studies, things like that.
Right.
All kinds of boring stuff. This is to the point, never a dull moment. It's a good book to read, and I think she's probably the world's leading authority, Dr. Sandra Kaufman, on supplements and stuff.
Do you know her like on a personal level, or
because of the book?
Okay.
So I read her book, and I thought, okay, this woman needs to be part of our clinical study. She needs to be one of the doctors managing our clinical study, because I want to, in our clinical study, I want to have every biomarker of aging tested possible.
Perfect.
She's it. So she's now on our clinical study.
Oh, that's incredible.
She and I have spoken at conferences. She's actually now a speaker at this upcoming RADFest. So yeah, she's remarkable. The other person that I think is pretty remarkable is Dr. Caldwell Esselstyn, who is, I think, one of the leading authorities on reducing inflammation. It's pretty tough. I mean, the things, but it's pretty believable that he's not only got a book. Well, by the way, books aren't peer reviewed. Scientific publications that you can find in PubMed are peer reviewed. So you want to see that these people actually have done that too, which is really important here. Caldwell Esselstyn has, and he talks about how, like, meats, and fish, and fowl, dairy products are all inflammatory. You pretty much have to go on a vegan diet, but you got to do more than that. Like the rumor that oils are good for you, olive oil and canola oil and things like that, is not true. I mean, they're actually quite bad for you. It's like I avoid all oils completely just because of the fact that they're inflammatory. There's other things like even coconuts and avocados. They're favorite vegan foods, but you don't want to eat those because they're inflammatory. So that book talks a lot about that. I live a diet based on both of those books.
Okay.
But I also get blood tests all the time. Inflammation is the #1 biggest problem. That's the #1 cause of aging. And you want to reduce inflammation that causes cardiovascular disease, increase your risk of cancer, causes everything. So I do blood work like every 6 months. My favorite company is a company called ALCAT, or the test is called ALCAT, ALCAT. I forget the name of the company that actually performs it, but every 6 months I send for a kit, I go get a blood draw, They give me my results. They tell me what foods I'm sensitive to. It changes all the time. And I just avoid the foods that cause inflammation in me. I think that's important. But exercise, in Kaufman's book will talk about like the importance of vitamin D and antioxidants and omega-3 fatty acids and things like that. Even though I say I avoid oils, I take my omega-3 fatty acids.
Fish oils.
Yes. And actually now I'm taking more of a kind of a synthetic fish oil that's called Vespa, I think it is.
Okay.
And
I think you mentioned that in Ben Greenfield. When Ben Greenfield interviewed you in January, I think you mentioned that.
Well, Ben Greenfield told me about another company like ALCAT named Cyrex.
Yeah.
Okay. I have to confess that dealing with Cyrex has been more trouble than it's worth. I don't know exactly. I have spent months just trying to get tested by them. They're very difficult to work with. Only your doctor has to be the one that prescribes it. Then your doctor has trouble getting them. I've had 2 doctors say they're just too much trouble. I won't have anything to do with them. But I did finally get my Cyrex blood drawn and sent. I'm still waiting for the results.
When did you send it in? Do you remember?
I would say it's been 3 weeks now.
Wow, 3 weeks. Okay.
No, I'm surprised I haven't heard back. But there was when I finally got it to where I could, they let me order the kit and I paid for it and everything like that. 2 weeks later, I called and I said, I still haven't received my kit. And they said, well, you never asked us to send it to you.
Are you kidding me?
And I said, what? Why would I pay for it?
Right.
And I said, do you have my address? And they had it all right, but they didn't send it to me. So then they sent it to me, and they said it was going to take 10 days. So I had to wait another 10 days.
And that's horrible customer service.
I know. It's just, I'm not, they do a test called the ELISA test,
okay.
Which is, I think, real important. It's different from what ALCAT does. ALCAT more looks at the size. When you induce an inflammatory response, the immune cells will actually get bigger. So they use that as a test. And I think that's a pretty accurate test too. But it'd be nice to compare the two.
Right.
And but now it's like months between the 2 tests. Now I'd have to do it again later to get the results to compare the 2.
Thanks for that. There was a test that we were talking about a little bit off camera that my wife and I have done. Yeah, Viome.
I'm doing that.
Yeah, it's Naveen Jain is the founder of the company. I don't know if you know him. He founded InfoSpace back in the 90s during the dot-com boom. It became worth like $8 billion. He worked at Microsoft before then, and Bill Gates was like his, I don't want to say mentor because he worked at Microsoft. Bill Gates is more of like his idol, essentially. He's a really brilliant guy. I've watched many of his lectures on YouTube. He's taught me a lot just from like learning from him. And I've come to believe that like the microbiome is super important. Whereas
I do too.
If you asked me 3 years ago about the microbiome, I'd say, what? What is that? So I've learned a lot about it. They have a 50-page book they send you via email when you order. I made an 8-minute video that kind of describes what the kit is and what it does. And I'm going to get to an update video. I've been eating the diet, my personal Viome diet for the last, 5 weeks, Lauren, we've been doing it. And I'm feeling pretty good. It's anecdotal. They say 90 days is what you need to kind of tell. So I'm following it. I'm trying to do the best I can. I haven't eaten any of the avoid foods, so
Well, I'm really good at that. My diet is unbelievably complicated. I mean, it's like,
you want to live forever. Like, you're a really good.
I'm obsessed.
That's why I'm here too. Like, more people should be studying you with like all the things you're doing.
There's restaurants in town that know me.
Yeah.
And they have prepared special meals for
me.
me.
Know
so
what
when I have
serve
a
you.
company meeting or something like that, we go there and they prepare. They'll let everybody else order, but they make a special meal just for me.
That's fantastic. I guess, so final things, you talked about lifestyle and those things. Other things that I'm interested in are like the NAD plus infusions and certain pills. And then, I developed a little bit of a relationship with Jesse Carmazin, the founder of Ambrosia, that's doing the human young plasma transfusions into older people, which unfortunately they got closed down a couple months ago. I've been out of touch with them, but out of all those things, other than telomeres, you got the human young plasma transfusions and NAD plus. You get all these other type of things. My friend Tom, who's super interested in the mitochondria, he's talking about bioreactors. There's a company called Platelet Bioreactors. What is the most interesting type therapies that you've looked into or that you believe in? Other than the ones we've talked about, I guess.
I don't like the word believe.
Okay.
Okay. So, but because I don't really ever believe one way or another. I just like to go with the data.
Right.
But I'm very anxious to see how some of these things test out. Okay, one thing you didn't mention was senolytics.
Yeah.
Okay.
That's a big buzzword.
Right now, the big ones are senolytics, NAD, parabiosis. I mean, those are probably the big
stem
three.
cells, but those have been
stem
around.
cells they've been around for a while. But
right.
I have my reservations about all of them. I have my concerns.
Right.
But
you're not rushing out and getting NAD infusions, right?
Well, I'm taking Elysium Basis, which is, I think, probably the best thing you can do to increase your NAD, short of like the big IVs and things like that. But so that's my solution, and Kaufman talks about it too. Elysium Basis, which is nicotinamide riboside,
right?
Which is I think the best thing somebody can do to get their NAD levels up. But I'm not convinced that it's important to get your NAD levels up.
Okay.
Okay, we're not mice. Okay.
Okay.
I think more
so why are you taking it?
Because why not?
Okay.
Okay. I'm obsessed that if it doesn't hurt me, I'm going to do it. Okay. Even if I don't necessarily believe it's going to work, I still do it. But I can't wait to see more human data. Parabiosis, shoot, what's going on there? I mean, that might be just a way of providing the body with cells that have long telomeres. Okay, that might be totally a telomere-based thing.
So real quick, what I've learned from kind of researching it quite a bit and speaking with Jesse Karmazin, I didn't know this, 2 years ago or 3 years ago, but the plasma has at least 2,000 proteins in it, and what at least right that we know of. There could be millions, like we just don't know.
Well, there's 25,000 different genes,
right?
And then a lot of those genes can produce more than one protein. So I'd be expecting more than 2,000.
At least 2,000 are the ones that they've kind of tracked and that they are tracking, and the ones that they know seem to be most important. When they've tested them, they've had improved the biomarkers of making people younger. Those ones are more prevalent in the younger people, and then they get lower as the people get older, right? So there's all these data points that seem to make you think that those proteins...
Now, are you sure that you're not talking about mouse data? There's people data that's showing this?
I'm talking about people data, and this is from speaking with Jesse Karmazin of Ambrosia. So this is kind of inside information.
I'd like to see that study. I mean, so because the lack of scientific peer-reviewed studies in humans is one of my concerns about parabiosis. But if that data is now existing, I haven't seen it yet. I'd like to see it.
So the real quick story on this is Jesse Karmazin graduated from Stanford with an MD degree in 2016 or 17, I believe. He's basically my age. He's like 34. He wanted to do this because he was doing work with this at Stanford, and so then basically there's all these companies and all the scientists are saying, don't do it, let's work on mice more. We need more research on mice. And he's like, I want to do this on humans, right?
Do it, yeah.
But he didn't have a whole lot of business background or funding, so he's got a medical degree, probably a ton of medical student loan debt.
He did a pay-to-play model. I think I'm a big fan of his. I'm glad he did this.
Right. So that's what he did. He started off at $8,000. He lowered it to $4,000 for half a dose. He started offering that as well. And from what he told me, this was in late 2017. He had done 80 people at the time, including himself and his dad, and he only tested 5 biomarkers, not telomeres, which he wanted to, but it was too expensive. But from the 5 biomarkers that he tested in those 80 people, they all showed biological aging reversal.
I don't disbelieve it. I'd like to see that study, but I can tell you that if he ever needs a job, I'd hire him. Because we need. I'm
gonna get back in touch with them, and maybe I'll try and put you guys in touch. Yeah. So that's something I'll have to do.
So parabiosis, I don't know what's going on there. I'm really excited the fact that people are doing. He's not the only one doing it. Life Extension Foundation's also doing parabiosis.
Right.
Senolytics, I have my reservations about that.
Like the drugs they're trying to create for senolytics is what you're...
and drugs are already created. There's actually, you can buy now denacetinib and
denacetinib and quercetin,
those, you can buy those in Florida right now.
What about metformin?
I've been taking metformin for longer than it's been available.
I got mine from Thailand because that's the cheapest place. You don't need a prescription.
I've been taking it for over 10 years. 2 grams a day for over
2 grams a day.
But the senolytics, my concern is, again, mice and humans are very different animals.
Okay.
I believe that there's a high probability that a 90-year-old person, their skin is probably 90% senescent. Okay, senescent cells aren't dead cells; they're still alive. They just don't lose the ability to divide anymore. If you do something,
they have lost the ability to divide. Is that
they've lost the ability?
Okay.
They're still alive. They
Okay.
just lost the ability to divide.
Okay.
But they can be overcome by lengthening telomeres. It used to be thought it was irreversible, but my research and stuff has shown that we could bring them back. But I'm afraid that if we treat a person with a senolytic drug that's like 90 years old, we're going to kill 90% of their skin cells, and that's going to kill them. So the question is, do we want to really get rid of all those senescent cells if we don't have a way of lengthening telomeres? I believe what we need to do is we need to be doing a combination of senolytics and telomere lengthening. Okay, that's the solution. But I'm afraid, I'm anxiously waiting to see the results, and if it starts working really well, I'm going to be the first one to start taking senolytic drugs. But I'm worried that this might be too harmful to humans. So senolytic drugs, NAD. In our clinical study, we definitely have NAD being looked at. We're very interested in that being a biomarker of aging.
From the Elysium pills people are taking?
Elysium, so Elysium Basis, that's Lenny Guarente's, he's the chief scientific officer for that company.
They're more of a Boston-based company, right? A lot of Harvard and MIT former.
I don't know where.
Okay, I think just from my research, and that could be wrong, but that's what I thought. One other thing, just regarding lifestyle, intermittent fasting. You do ultra marathon running. You're skinny. Do you do any of that, or do you believe in that much, or?
Yeah, it's like my latest discussion with Joe Mercola was. I would if it wasn't so troublesome. I mean, I believe in fact, Joe Mercola, who I'm a big fan of, he's actually now talking about partial intermittent fasting, which is he's doing studies on right now. I'm really anxious to see how those turn out. But I've never enjoyed fasting. Okay,
I've built up a tolerance for it. Yeah, it's not. Yeah, it's not for everybody.
I like eating. I hate being hungry. But it's probably good for you, and maybe there's a line I draw. I'll do some things, but I won't do everything. And maybe soon, the older I get, the more likely I am to start doing everything. So fasting might be one of those things. But I have nothing against fasting. I don't think I think there's a lot of really solid, good data. The reduction of autophagy and stuff like that is, I think, critical.
Because that's basically doing senolytics naturally, essentially. By getting autophagy or. Yeah. I've heard people pronounce it autophagy. The scientists pronounce it autophagy.
And there's people who pronounce telomeres and telomeres.
I know. And I heard you saying mitochondria as well, too.
Mitochondria, yeah. It depends on, when I was in school, how did my teacher pronounce it?
Right.
That's what you get. Well, there's another one that's really different.
All right, unfortunately, we've ran out of time. This was a lot of fun. Dr. Andrews, are there any closing thoughts or anything you wanted to share? Shout-outs, anything, plugs for any products or anything?
Well, I definitely wouldn't plug any products except this product. I definitely want to continue this on another occasion when we can talk more, because I actually have so much to say I could talk forever. So
awesome.
I think we only scratched the surface today.
I definitely think so as well. I had a lot of fun, and hopefully we'll be able to do this again soon.
All right, had fun. I enjoyed it.
All right, thanks, Dr. Andrews.
All right.
Yeah.
I do consider the discovery of telomerase one of the biggest medical breakthroughs of all time.
Yeah.
And this picture here shows when we actually first discovered it in 1994. We discovered it in 1993, but we actually got convincing proof that anybody would believe it in 1994, and actually sent this email out. And this is the team of scientists that I work with. You can see me there when I had a beard. But we consider this so major that we all got together for a 10-year anniversary to celebrate the discovery of telomerase. And we're still waiting for it to be the biggest medical breakthrough of all time, but we just know it's going to be as soon as we get certain amounts of research done.
And this is when you were at Geron in Menlo Park, right?
Geron, but this is now, after I was already here, we just reorganized it near Geron Corporation, got everybody together and took a 10-year photo. But it's still It's going to happen. Just
I-
we have to get past the research stage.
They completely mapped the full enzyme last year, so that's pretty cool.
That's completely irrelevant.
Yeah, oh, really?
I mean, that's.
I thought it was cool just to see what it looks
No,
like.
I mean, we knew what it looked like.
Okay.
From the day we got it.
Okay.
Okay, it's.
Well, what does that mean then? Because like Liz Parrish posted something like, "Here's what it looks like."
Let's get away from the office.
Yeah.
Tell you more about it. Let's just stand right here. Let's go down.
Okay.
See.
Yeah, it's a little.
Probably should do this with the lights on. We just turned all the lights off here.
No worries.
How do I do this? Okay, so the big problem in science is that most people are just trying to make a buck.
Right.
Okay, and they're trying to do, or they're trying to make themselves famous,
Right.
or something like that. And that seems to be the main driving force in a lot of science, and not the actual science.
Right.
Okay, so people are constantly publishing, making press releases. They'll do a study, publish it, and then make a press release, and they'll say something like, "Nobody's ever done this before. We're the first," and stuff like
Right.
that. But shoot, we did it 20 years ago. You know,
Right.
it's that kind of stuff, and it's like really troublesome that there's so many people out there that are more focused on just trying to make themselves famous or try to make some money, and they're not emphasizing the need for actually getting some good science done. Okay, and that's what's really got to get done. And so, like, for instance, we don't sell anything here. Okay, the only reason I ever get a talk on stage or anything like that is because I need research funding.
Of course.
I need funding for my research. I never make any false promises. I never do anything like what most of these people are. But it seems like every day I'm reading some press release. In fact, there was just one just a few days ago about getting rid of senescent cells, and it says, "First time ever, old cells turned into young cells." But all you got to do is go back and look in the papers in the 1990s where we did that by just lengthening telomeres. We
Right.
turned old cells into young cells in every way imaginable that you can measure.
You mentioned that in your book.
Yeah, I mentioned that in my book, but others have reproduced it over and over again. But then somebody else is just trying to make a buck, tries to pretend, "Hey, nobody's done this before, I'm the first."
I do want to say this when we have the microphone set up and we're sitting back down, but and maybe we'll just do this all over again. But do you think that how much of that, from your experience, is people being disingenuous, and how much of it is people literally just not understanding that this has been done other places, so they think they're the first? You know,
It's the first thing.
You think it's
what's
normally
that
the
word
first?
ingenuous?
Disingenuous.
Disingenuous. That's
They know that they're lying.
yeah,
In other words,
It's like and
you, from your experience, it's normally that.
yeah, because it's not hard to do a Google search or
Right.
a PubMed search to find out that somebody's done this. But that's
I've personally seen it dozens of times.
if they
Yeah.
didn't know, it's only so they have plausible deniability. Okay, because they could have found out without any trouble at all.
Right.
And then I guess there's a lot of times when people actually don't know, but that's because they're so narrow-minded that they don't think about anything else going on in the world except their own research. Okay, and so that happens a lot when people start talking, like people doing research on oxidative stress, and they think that oxidative stress is the #1 cause of aging. And then, I'll meet them at a conference and I'll say, "What do you think about telomeres?" And they'll go, "What's a telomere?" It's like, I pride myself in staying on top of everything. In the conference room we're in, papers everywhere. Well, that's because I need to stay on top of everything. And plus, with the clinical studies that we have going on right now, I've got to be able to stand up in front of audiences and address every single kind of question.
Right.
Which is also one of the reasons for my books, is mostly to just answer all the questions people ask me all the time. But I need to stay on top of all of it. And there's so much, I've said this many times, but there's never been a field with more quacks and charlatans than the anti-aging field.
Yeah.
Cleopatra and Ponce de Leon and all these people, they were all full of crap. They were just trying to, or maybe they believe, some of them believe some of the things, but they were being fed by people that were just giving them a lot of crap.
Right.
So the struggle here is to try to be able to continue to get the science, continually let people know that this is a place worth putting funding into and not letting these other entertainers, I like to call them, pull them away. Because there's companies that have been big companies where billionaires are actually funding them and stuff like that, and they're completely run by entertainers that don't do anything.
Yeah.
And you and I already mentioned one of them.
Yeah, definitely.
So
This is one of the labs. That I should have turned on all the lights before we started the tour.
No worries.
But this is a lab where we right now mostly do natural products, and it's like these boxes here. They're loaded, every single bottle, tube here, let me pull one out, has a different natural product in it, extract. That's a powder, some plant, we don't know what it is, they're all blind to us. Some plant was ground up to a powder, and then
is it a third party that knows what it is?
Oh yeah, we see, the only reason we would do something like this is to generate funding to fund our research.
Right.
Our company isn't really focused on natural products. I think there's a good chance natural products could someday be potent enough to actually reverse aging.
Are there molecular derivatives, in other words, too, right?
There's molecular derivatives, but if you find a plant that has the ability to induce telomerase and lengthen telomeres a bit, but not enough to win the tug of war between the shortening.
Right.
You could find the active ingredient inside there, study it, and modify it to make it better.
Right.
As soon as you modify it, it's not natural anymore.
Yeah.
Okay, so that's the downside of natural products is we can't make them better. Okay, so we focus on the pharmaceuticals, and one day we hope that when we find some pharmaceutical that's strong enough to reverse aging, then we can search all the plant molecules to find out if one already exists in nature, and then we have a natural.
That's super close in molecular structure to
Yeah.
the pharmaceutical grade one.
Yeah, so that we wouldn't have to modify, and that would be the fastest way, I think, because if just doing what we're doing here, we've tested over 10,000 different natural products, plant extracts, and we've found several plant extracts that do induce telomerase, but none of them come close to our synthetic chemicals,
Right.
our pharmaceuticals. And but even our pharmaceuticals haven't been potent enough to actually reverse aging yet. Aging and telomere shortening is like a tug of war. There's shortening and lengthening going on at the same time. There's aging and anti-aging going on at the same time. It's kind of a tug of war. But nothing has ever been found that actually wins the tug of war to lengthen or reverse aging. Just slow down. The things that, like the natural products and the synthetic products, they slow down the rate. But the synthetic products slow it down better than anything else. Now that said, we do have a gene therapy, which is very different from natural products and synthetic chemicals. This is like a virus that we infect people with to deliver the telomerase gene. And in that case, we deliver about 30 times more than is needed to win the tug of war. So the telomeres actually get longer. We've tested this numerous times in human cells in a petri dish. Other labs have tested it on mice or human skin grown on the back of a mouse. Works beautifully, but it's just a little difficult to do it in humans, plus the gene therapy that we have right now that we are presently testing. We're just getting ready to, we've done baseline studies, we're just getting ready to treat our first person. That costs about $700,000 to treat one person once. That's our cost. Okay, so that's why that's never going to be something that everybody's going to be able to buy.
But isn't that price going to drop dramatically in the years? Like,
I don't know how.
Okay, because I have no idea why it costs $700,000.
To produce enough of the gene therapy is super expensive.
The chemicals, like to create
There's
them?
no chemical. The growth media, you have to grow human cells in a bioreactor. You have to infect. You have to harvest. You have to purify.
But all that stuff eventually, you say never.
Yeah, never. No, the
eventually
reason I say
the
never,
prices will come down, right?
The reason I say never is because in the meantime, from the billionaires that are going to pay to have themselves treated with this gene therapy,
right,
we're going to be making enough profits or royalties, let's say, to fund the research so that we can continue our small molecule drug. And I'm absolutely certain in 1 to 3 years, we will find something just like a chemical, a pill, that's just as potent as the gene therapy. And therefore, why would anybody take the gene therapy when it's even if it dropped to $500,000? Why would somebody pay more than the 10 cents that it would cost to take the pill?
Okay, I have so many other questions. I want to do it when we're doing more of the interview with the microphones on.
Well,
This can be better.
So I don't know how.
I really wanted to ask that question, but I'm gonna.
I just talk whenever I feel.
I do the same thing too. I need to.
Yeah, so let's go. So this is the lab where we normally look at the natural products, get them at least set up. It's the whole company here is involved. This lab is our molecular biology lab. So all the gene cloning, gene engineering, genetic engineering is done in this lab. I mean, a few hours ago there were scientists in here, but then we couldn't have done a tour, you know.
I don't know if you remember this, but about 3 years ago, I started taking a cheaper cycloastergenol product.
Cycloestragonol.
Cycloestragonol.
Yeah.
From just Amazon. It's called, I think it's Nature's Best was the name of the brand. And it's so much cheaper than TA65, and they basically say it's the same thing. So I tested it out, and I called you up. This was back in, I think, 2016. And I just said, hey, I don't know what I'm taking here, because the way, you know, nutrigenics work and, nutraceuticals work in the U.S., basically, you know, they're not drugs. They don't have to be FDA approved or regulated. And you said, you know, I could test in my lab, but it costs about $4,000. And I was like, well, I just bought this in bulk for $1,200. I don't think it's going to hurt me. So I'll just take it first and see if, and you know, I thought it was helping, but where would you test that? Was that in that room that we were just in?
No, it's the whole company. So
okay.
Part of it, for weighing it out would have been in that other room. Setting up cells and genes and stuff like that would have been in this room. I'll show you the rest of it, but I got to tell you that we've tried comparing TA65 to cycloestragonol, also astragaloside 4, astragaloside 7, others. We've never been able to get any of the other ones to actually induce telomerase, but TA65 does every time. I don't know what TA65 is. TA Science has never told me. There's a rumor circulating that it's cycloestragonol. I don't believe it, because
because that's what came out in the European Union, because the European Union does make you disclose what's in there, so they basically said it was cycloestragonol.
I think they're lying.
And
I think they're lying to keep anybody from trying to figure out what TA65 really is.
Because they knew as soon as people found out what it was, they just start making that.
Yeah,
it makes sense.
And I try my best to stay out of that kind of business. I'm a scientist. It's more marketing, trying to get a buck. I have to stay away from all that kind of stuff.
That makes sense.
So I just can tell you the data. The data says cycloestragonol doesn't work in our hands.
Okay.
This is our kitchen, glassware washing, flammable chemicals. One exciting thing that we have here, this is outside, I like to show people. When it's raining a little bit, we used to have really wealthy investors.
Before the crash of 08?
Before the crash.
Yeah.
They bought us this thing here. This is a Rolls-Royce jet engine inside this box. And when the city of Reno has a power failure, we never see a light flicker.
That
anywhere.
Is crazy.
This is all propane coming in. It's still operating 100%. So,
and look at these mountains over here. It's beautiful.
Yeah. We like being here because I encourage people to get out and go for a run, and those mountains are always a great place to learn about that.
Okay.
It's like we'll get knocks on the door sometimes, and people will say, "How come your lights are on and everybody else's are off?" And we didn't even know they were off. We didn't know that everybody else was shut down. This is a walk-in refrigerator. Essentially, we do a lot of our experiments in the cold, so people wear ski clothes even on a hot summer day, just to work in here.
And this was founded in 2001, right? Is when you
1999.
1999.
So we moved to this building in 2001.
Okay.
Our first 2 years, we were on the University of Nevada Reno campus. We had an incubator program where we had labs and offices there for 2 years. And then after we had some success, we moved out here. We're going out of order, but this is where, when we test something for telomerase induction, this is where we actually see the final results. And this screen right here, this just happens to be left open, but we'll stand around here. Look, this is a real-time, what's called PCR. Okay, PCR stands for polymerase chain reaction. Mm-hmm. And if we have, and so this is like a 380 well plate, it's 384 well plate, which means there's 384 different test tubes right there. And so we will test 384 different natural products or synthetic chemicals. Every one of those will contain cells. They've been treated with different drugs. They're incubated to see if the drug causes those cells to start producing telomerase. We then can detect the telomerase by sticking it into this machine, okay? And it then reads each of those wells by the method called PCR. And what we'll stand here and we'll watch, okay, so this every line here represents a different hole. They're all being analyzed at the same time. After a certain number of cycles of PCR, they're all still the same. But then all of a sudden, some of them start to go up, which is saying there's telomerase being produced in those cells.
Are those human cells that are
Yeah,
in there?
we only work with human cells here.
Good.
It's like...
I've had enough with mice. I want to cure aging in humans, not
everybody
mice.
acts like we all age the same way, but
Yeah.
it's like aging is so unique to every
Right.
different life form. It's like mouse data is almost meaningless. I think rodents are one of the least similar to humans of all the mammals and stuff like that that exist.
They age a lot by oxidative stress, which is why a lot of scientists now still focus on that so much for humans, but it's just not as important.
You're familiar with the Hayflcik limit, right?
Of course, yeah, John Hayflcik, yeah.
Oh no, Leonard Hayflcik.
Leonard, thank you.
Leonard Hayflcik.
He's in San Francisco.
He's north of San Francisco.
Yeah.
But he showed that human cells, when you divide them, will divide a certain number of times and stop growing.
Right.
Well, mouse cells do the same thing. You take a mouse cells, and you start dividing them. They divide a certain number of times and stop growing. But mouse cells, you can get them to overcome that Hayflcik limit by adding an antioxidant. An antioxidant has no effect on human cells.
Yeah.
Human cells, you can get to overcome that Hayflcik limit by lengthening telomeres, but lengthening telomeres in mouse cells has no effect. So it's like the same phenomena occurs, but it's for totally different reasons, which makes it completely nonsense to be even trying to study this in mice. And people keep acting shocked when I tell them this, and I say, well, look at how many papers you can find that talk about overcoming the Hayflcik limit with telomerase in human cells. Now find one paper that says the same thing about mouse cells, and nobody can. There is not such a paper.
When I was in college in 2005, I learned about acai, the berry. It's the highest antioxidant fruit, at least from my research in 2005. I've learned that it kind of was, that's before Oprah popularized it in 2008. So my roommates thought I was nuts because I would go to Whole Foods in Lexington, Kentucky. I went to University of Kentucky, and I would buy massive amounts of acai juice because I thought I'm having all these antioxidants. I'm going to be preventing and reversing oxidative stress. But
they are good for you.
They're good, yeah. But I wasn't.
But not nearly as you aren't going to benefit nearly as much as a mouse would.
Exactly. Okay. Yeah.
Now that said, I actually believe the best way to get your antioxidants is from the purified, isolated forms. So I go. Alpha lipoic acid, vitamin E, vitamin C, things like that. Sometimes, people talk about blueberries and acai and having a lot of antioxidants. I think you get much better results from taking the individual ones that are more concentrated, more purified, and there's more
bigger
data.
Doses, right?
And more, Well, doses when it comes to antioxidants, too much can actually can cause an antioxidant to become a pro-oxidant.
Right.
And cause oxidative stress. So you got to stay within certain margins. And then a lot of antioxidants work in different areas. That's why I take more than one kind. Some are really specialized for your cardiovascular system. Some are specialized for brain function, things like that. So I take a bunch of them myself. Yeah. Let's move out of here now. Let's. This skipper room here. I want to go take a look.
Okay.
These are. We've got a broken centipede. These are incubators. We store all of our cells. These are minus 80 degrees centigrade in there. And I should show you this. I do believe that yoga and things like that is a great way to help keep your telomeres long. I've actually spoken at conferences about it and stuff like that, but we have our own yoga room. And
we do yoga and just do weight training like this all the time. Gotta stay.
In addition to the running, look how okay, so this is our microscope room, or one of them. This is it's a regular light microscope, but it's like powerful enough that you can't find a light microscope more powerful than this. It actually goes through all the way wavelength of light in analyzing things. So we use this a lot in our studies. Pictures from cells on the wall here. And we use a lot of fluorescence to identify cells that are producing things. There's some even are, we have different colors of fluorescence. So there's some missing pictures. Oh, they come and go. I don't. Well, the people that actually use those are in control. So this room is where we grow a lot of our cells. More basic prep is done in here, but we actually come in here. And these are called different names: tissue culture hoods, cell culture hoods. It's like you sit down here at the chair, lift this screen up, reach your hands in here, work on cells that are growing inside there. Air pressures keep any bacteria or anything contaminated from going in there. And then we actually grow our cells in those are CO2 incubators where they're designed to have the best environment for human cells to grow in petri dishes and stuff.
So how fast could you take one cell and turn it into a billion in a petri dish in there, like a human
cell
cell?
divides about every 24 to 30 hours.
Okay. If it's young, or is that the same for like an 80-year-old?
An 80-year-old, well, when telomeres get short, then they start slowing down.
Right.
But they're still, it's like, it's not a gradual slowing down. It's like if you look at like the Hayflcik curves, they grow at a constant rate, and then all of a sudden, it's not a real sharp change, but it's sharper than just gradual. But so if a cell divides every 30 hours, so it's 1, 2, 4, 8, 16, 32. You can do the calculation.
It gets really big really fast.
Well, actually, some people are surprised how long it takes. Sometimes it takes like a week or something. But I'd have to sit down and do the math. A lot of times, when we need to grow a lot of cells, we've had like these big, what are called cell factories growing in here, where they pile up on the floor with growing cells, we turn whole rooms into incubators.
Wow.
And that sometimes can take like weeks to actually get all the cells we need. This is a liquid nitrogen tank. We store a lot of our cell lines in there. That's like it's colder than outer space. Okay, so we've been there. Let's go back this way. This is a transition lab. We have a little bit of everything in here: a PCR hood, a tissue culture hood, incubators and stuff like that.
Polymerase chain reactor.
Polymerase chain reaction. But the reason why we have this transition lab goes way back to the O.J. Simpson trials. Okay?
That's not what I was expecting to say.
What they were able to do is they were able to show that the scientists, the doctors, were able to show that O.J. Simpson was guilty.
Right.
Because they used a machine exactly like I showed you there for us, the PCR machines, to show that a blood spot contained his DNA, so that he was at the scene when his wife was killed.
His DNA was in her or in Brown's blood, one of them, or.
No, it was so there was blood spots on the ground around her body. There was his blood.
And that was his blood.
Yes.
Okay, I got you.
Okay, so, but his defense argued, but there's signs of other people's blood being there too. So what's going on? And they were saying, yeah, there is. What is this? And so they ended up finding out that there was also signs of the scientists that were actually studying the blood. Some of their DNA got into their samples and was showing up in PCR, and it invalidated the whole data. So O.J. Simpson got off, even though the blood showed he wasn't there.
He wasn't a scientist there working on it. How did his get in there?
Well, his was there forever. They said the test was completely invalid. So PCR.
That's why our court system is corrupt.
Well, no, it's actually it actually could have been for real. But at that time PCR was so new, it was considered invalid. Is she okay?
Let's just hold on a second. Hey, Lauren, you cool?
Yeah, sorry, I just started getting
little woozy? She's pregnant, by the way.
Okay, all right.
So she's like 17 weeks pregnant.
Okay.
We'll just...
All right. Well, so O.J. Simpson got off because what turns out that PCR is so sensitive at detecting DNA that even somebody's sneeze or sweat or something, molecules floating in the air can contaminate and show up as signals in this PCR. So we have this, so all labs who do PCR now have this rule. You don't let PCR go back and forth between different labs.
Okay.
So this is a transition lab. Everything I've shown you so far in the building gets finalized in here and then put through here. You know,
Oh, wow.
this looks like a urine collection thing at the hospital. But we put it in here. Oops, just there. And then we walk around, and you will see a sign right here that says no PCR beyond this point. And we can thank O.J. Simpson for that. Okay, so now we go through here. This is the only passageway to the other side of our building. It just makes certain that we don't get any contamination. And by the way, you'll see data all over the place here.
Yeah.
Studies we've done. We usually don't spend a lot of time publishing. That's for academic labs. But when we discover something important, we think we need to let the world know. So we'll do posters at conferences. But we come over here, we take the sample out of here, and now we go to our robotics. So our robots, which I can't turn on today, are in here. If you could pull that door closed.
Yes.
And you need to step on the blue pad
Okay.
to get this dust off your shoes. And if you come in here, you got two robots here. Everything from here to here is one robot. Okay, this moves around. Let me just find an example. See, this would be a 96 well plate. I showed you a 384 well plate before. This has got 96 different test tubes. And so experiments we've done in here, this has these arms that pull down here that will grab this plate and we'll move it around from place to place. We'll mix things together. These things here will add and remove liquid. So this one's a minor one. This one over here actually does even more. It's got this robotic arm. It'll carry this plate up and down this rail from that end to this end. Put things in here, put things in here. It will, like, let's say if the robot mixes a bunch of stuff. Well, here's one already here on here. It will shake it. Okay, the robot arm will put it there, take it off when it's done. Do a bunch of things. Again, here's another one of these what are called liquid handling stations, where a lot of the research is done. Then the data gets piped to that other room where I showed you this.
Right, with the computers, yeah.
Let me put this back where
Okay.
it was.
So this is really the robots that are doing the work to test for different molecular structures that can induce telomerase?
They're testing for chemicals that will induce telomerase. The chemicals, they don't study the chemicals. The chemicals are added to each well. These robots ask the question, which cells are producing telomerase as a result?
Okay.
Let's go this way.
Okay.
This door. So, the number one most important or biggest obstacle to, let me turn this light on. Biggest obstacle to getting research done is funding.
Right.
You know, and it's just like, it's unfortunate that we've got all this great science we can do, but we're limited by how much we can do by the amount of funding we have. Well, so in 2008, we were moving into this room to build all of our chemistry labs. When the global financial crisis of 2008 hit, our investors lost the ability to fund anymore, and I've been keeping this company alive based on licensing discoveries of ours to other companies that turn them into products and sell them, and then we get a royalty from that. The only condition is that I don't have anything to do with marketing.
Right.
I want to just do science. I don't want to market. It makes me sick seeing all these people out there trying to sell themselves and trying to mislead people.
Yep.
I just want, for the first 10 years of this company, nobody even knew we existed. Even our next door neighbors here had no idea what we do. I always said, one day Betty White's going to walk out on stage.
Yeah. She's
going to look and feel and behave 25 again.
Yep.
And then we're going to say, guess what we've been doing the last 10 years? And now it's 20 years. I'd still like that to happen. But the world isn't as nice as it was before 2008, where investors could be putting in all that. We were spending $1 million a month back then to do what we have done. And now, right now, we probably spend $100,000 a month. So we're low. And actually, in 2008, when we were building this room, we were planning on going to spending a lot more than $1 million.
Right. You were growing.
Yeah.
So, I mean, just so you know, my intentions for doing stuff like this is to help just bring more awareness. And even if it's starting small and it doesn't get a lot of views, but I'm trying to do whatever I can at this point, because I've heard you basically say that a number of times on interviews and lectures, and I want, all it takes is a Jeff Bezos or a Larry Ellison or whatever, or even guys smaller than that who have $2 billion or something. Just takes one of them.
Yeah, I know.
To buy in. And
I've done hundreds of these kind of interviews.
Right.
None of them, and I've been in popular science, featured in popular science.
Immortalist documentary, right?
None of that ended up getting us anywhere. And the problem I look at it is the Bezos guy and others and stuff. They are too influenced by the entertainers. Okay, and I've used that word before. They're influenced by the entertainers. They get talked into putting their money somewhere else. I'm just not one of these entertainers. I feel like I am. I get up on stage and I talk to an audience. I feel like I do a really good job, but I don't ever bullshit people.
Right.
I tell them the truth. I'd say, we don't have anything yet, but we're doing research to find something.
Right.
Well, somebody else will tell some of these billionaires, oh, we already have something that works. We just need a little bit of money to turn it into a product. And then it turns out 10 years later, they're still working on the same thing because they can't actually get it to work. There's nothing on the planet that works. You can go to Google and you can do a Google
I've been to
search,
Calico's
everything.
office, the Google, I've been to their office. I met with the whole team. I didn't film it because they didn't allow me to, but I walked around with them and they were very secretive. I have no idea what the hell they're doing. And they didn't show me all the back end of this, but they're in South San Francisco. Who knows what they're doing? I mean, they were founded 6 years ago. I got excited when that was 2012.
For the record, I never said Calico. Okay.
That was all me.
Google,
Thank
I
you.
was talking about Google searches.
Okay, gotcha.
I'm not.
That was all me. That wasn't
Dr.
Dr. Andrews at all.
About any company or anything like
Gotcha.
that. There is a general tendency for companies to get really locked into the entertainers that really don't do anything except great talks and stuff like that. Whereas here we're trying to do real science. And why hasn't some of these companies, if they've got all that money, come up with cures yet? We think we can have a treatment that an affordable treatment everybody can afford, that people can take in 1 to 3 years from now. Okay, if we just had, it amounts to a little more, maybe $1.5 million a month.
Right.
Okay, that's how much it would cost to do the research, and we can't get that. Okay, and 50 years from now, we or somebody else is actually going to get this accomplished, and everybody's going to say, well, what took so long? Okay, well, it's the funding. And when I hear about every time you hear about, this is a funny thing, every time you hear about some big breakthrough on the news or press releases like that, 99% of the time you can guarantee it's not real. Okay, it's just some people trying to get attention so they can get money to do the research that will show that it's real. But they have to show it first, and it hasn't. This has been true for 1,000 different times. People have heard the cure for cancer discovered. Well, it didn't really get discovered. And there's all these things about coconut oil prevents Alzheimer's. No.
Might help a little bit, but that's not going to reverse aging.
No, it didn't help at all. In fact, the key people in the studies all died at the normal time. Nobody ever said anything about it. That's, who wants to hear that?
Yeah.
But I'll tell you, coconut oil just went through the roof. Everybody started buying coconut oil because some woman said her husband was getting better. Of course, when her husband died, nobody said anything about that. It's but a lot of that kind of stuff happens, and it's unfortunate. But I'll tell you that if we could, I've quit trying to look for investors. Okay, I'm just trying to see if we can generate our own funding. My business plans now that I write are mostly on, they're called like self-generating revenue plans.
Yep.
Okay, ways of us, because I'm looking not for investors, I'm looking for marketing partners.
Right.
Okay, we have things. We have on the shelves. I should have shown. We have on the
Become
shelf.
more self-reliant. That's
We have
smart.
the cure for aging in dogs.
Right.
We have the cure for aging in cats and horses, sitting on a shelf. Okay, we just need some company like Purina or something like that to say, oh well, can we put this in our dog food? Okay, well, we went to Purina, met with the top officials, and then they all walked out, and me and my team stayed there, and they came back in and said, we don't see a market for this. We were stunned. Okay, we were stunned. We had shown data that we could turn old dog cells into young dog cells. We showed that even other people have done research, published in scientific peer-reviewed journals, showing that can be done just by lengthening telomeres. But I don't know, Purina, for some reason, couldn't see. The only thing we hadn't done was we hadn't treated an actual animal.
Right.
Because that's kind of illegal. We have to get regulatory approvals and stuff. It's super expensive. We need somebody like Purina to fund the study to treat an animal.
Yeah.
And that's pennies compared to how much, everything else involved in trying to do this. But we've never been able to do that.
I want my dog
very
to stay
frustrating.
young.
Yeah, me too. I've got a dog, and believe me, before long, my dog starts getting old. I might just have some announcement, but I'm not going to tell anybody how I did it. I'm going to make my dog younger.
Our dog's only 5. I might talk to you off camera.
Okay. Well,
We love our dog. We don't want her to get old and die.
yeah. The unfortunate part right now is that the treatments we have for dogs, cats, and horses still cost like $500,000
Right.
to treat one animal once. And they work. That's what's great. At least they work in petri dishes.